right.
Alrighty, guys, we are here live. Finally, we are testing. We had a little bit of intermittent kind of issues we were trying to work through here, mainly because last time we were having some audio problems, and we wanted to make sure that those were going to be resolved.
So now we're going to be testing both of our audios. I'm going to talk for an extended period of time real quick because last time it was just for like 5-6 seconds and it sounded good. So I'm just going to continue to talk and talk and talk and just see if, as I do this monologue, there's actual substance and that it's not all glitchy and terrible. All right. So let's see. Test 1, 2, 3, and let's test this. Go. Perhaps now I won't be as quiet.
Testing. 1, 2, 3. Testing. You and me.
Testing. The birds and bees. Oh, yes, you see. Oh, yeah. Oh, yeah. Test 1, 2, 3.
I wonder if you have something. Let me check your. You're still lower than I am.
At what moment? Yeah, I did sound good there. Okay.
So I'm going to talk first, and then I'm going to throw it to Jacob.
Now I'm going to talk right now. This is where I'm going to try to stay the entire podcast right here, right in front of my microphone.
Now I'm going to raise the level as I snatch it back from Jacob, and we're going to talk a little louder, and then I'm going to throw it back to him.
And I talk a little bit louder right now. Ha 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 ha.
Now we're both going to talk at the same time.
Same time.
Same time. There we go.
Mm. Yeah. That might work. Ooh. Together. Oh, what's a nootropic topic? That no, I agree. That's something that I can talk pretty extensively about. I know that yeah, give me another bowl. Test 1, 2, 3. Testing 1, 2, 3. Does it actually sound good right now? Oh, that makes sense. Like, wait, it's fixed. Never mind.
Plus the uh fuck off. Plus you were speaking pretty low,
Yeah.
and I think that a lot of gain gives us some problems. So I might turn
Mhm.
down both of
Like
our
the gain.
gains a little bit. Um,
Right. Put on the lower end of
no,
3.
no, 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 no. You
On there.
keep yours where it's at because yours is compensatory to just for my
Okay.
sensitivity. Um, and I think I will adjust our both of ours after that
Okay.
down. Okay, so resting levels. It looks like from what I can tell here, my resting level is higher. No, actually, they're about the same.
Nice.
That's what it is. Well, I mean, that's why it appeared differently at first because I think yours has a gating mechanism built into it that will like eventually turn the mic off,
Oh.
like if a low enough signal,
Mhm.
low enough signal, and mine isn't. So, um, I think that small of a difference in mic versions would cause this much of a difference.
No, especially since it's by the same company as well. Both Yetis. Maybe you get one or you get my model. Make.
I think eventually, yeah, I should probably just update my model, but
I'm sure you can sell that one. It's a good microphone.
okay. So this
I wonder
is
if there's an extension that has that same gating mechanism. That could be cool.
a fast mechanism. me try medium here.
Medium.
Working on our kind of, there's like this plugin that's meant to design or meant to eliminate source feedback. So I have running on each of our mics, and it's kind of acts like a gate almost. So
Sweet. That'll help.
alrighty. Test. 1, 2, 3.
Test. 1, 2, 3. 1, 2, 3.
Yours is still lower.
Yeah. And
Okay, so try to match my volume here in a second. Test. Okay, yeah, it is lower. Interesting. Let me lower my gain.
must I?
Okay. Turn my gain down to 90, so let's try that now. Testing. Testing louder.
Testing. Louder.
Down to 80. Let's try that.
All right, let's try 80. If that does any
Testing.
testing. 1, 2, 3. Testing. 1, 2, 3.
Okay, this is weird. I now have two audio controls for each. It thinks my microphone is 2 mics.
Oh.
That's problematic. I'm going to change my settings here because something's wrong. Did you change? How did you change my audio source over here at any point? Because it's selecting both my default and my Yeti.
What if it was your laptop that was picking up my voice?
Well, it's selecting both my default and my Yeti. It thinks that my one Yeti is 2 separate mics. And so it had them both selected and was giving me a set of options for each of them. So it might have been doubling my signal.
Honestly,
because
if that fixes it.
right now my signal is looking lower. Hold on a second. But go ahead. What were you saying?
I was going to say, if that's the problem, I'll be very happy. Finally, the fix.
Testing.
Testing.
Actually, let me reload here. Now that I updated that.
Okay. Nice. No longer have 3 microphones.
Yeah. All right. Testing.
Yeah.
Oh, that level is looking way
Way
better.
better?
Oh my gosh. Way better.
Okay.
Holy moly.
Hell yeah. That'd be awesome if that was the case.
Match now. We still
Yeah.
have that
Okay.
little, but
Comprehensible.
yeah, we're matching as far as our
Mhm.
volume levels go.
Yeah, and there's, little to no echo.
Yeah.
There was, like, a tiny bit, but besides that, it's infinitely better.
Holy. Okay.
I'm gonna talk for, like, an extended period of time real quick so that I can know that that's the case. Alright. Hello, hello, hello. How's it going? Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3.
Now, keep in mind, I am connected to my computer right now,
Mm,
so my computer might be struggling to keep up.
but still,
So let me, first off, let me reduce the processing going on over here by um, taking the plugins that are not.
is this thing on? Audio.
Okay, I'm gonna flip through some modes here on this reverb reduction plugin. And I need us to, you did, you and me both to talk so that I can hear how each mode sounds. So I'll switch through them. We'll do kind of a sentence test and then another sentence test. And as I switch through them. Okay, so this is the first mode. So test,
Test,
testing, testing, 1, 2, 3.
testing, testing, you and me. Boom, boom, boom.
Okay. This is the next mode. Testing, testing, 1, 2, 3.
Testing, testing, 1, 2, 3.
All right, let's hear those two.
Right.
Testing, testing, 1, 2, 3.
3, 2, 1. Testing, testing.
Oh, that's worse. Yeah. All right, the back. See
Dialogue.
different model here if that will result in less static or less popping.
Sweet.
Testing, testing, testing.
Testing, 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 testing.
Testing, testing, testing.
Testing, testing, testing,
Testing
testing.
at the same time.
Testing at the same time. Okay, that one was the best one so far.
Yeah, that's I think. Let me try bringing it down a little, the processing down a little bit, and see if usage that is consuming, so that we can get rid of some of that popping. So testing again, 1, 2, 3. Testing. Jacob, why don't you throw us a test?
All right, and test. Ate a grenade test.
Oh, damn
Testing
it! Not
grenade.
again.
Oh, it always happens. The key to eternal life is eating grenades. Did you know that? I would catch your grenade for
Oh
you.
yeah. Wait, rewind it, because I feel like I cut out there.
You did. Yeah,
Okay, so I don't think that actually has to do with this. I think that has to do with
that's connection. Or oh, I see.
Row. Yeah, I think that's it. 'Cause some of that word was too quiet.
Oh,
So either I'm going to have to increase my or decrease my gate threshold, or maybe the speed. Test. Ooh. The
when the moon rises like a big pizza pie.
Okay, I'm gonna have to probably reduce. Might have to reduce yours too. We'll see. Can we hear any of that? Test. The first one did work, and then when I adjusted it, looks like it made it. I had adjusted it back. Give me a second. Let me throw it, Jacob. Throw it. Throw it. Throw it.
Throw it.
Mine sounds better because you can hear the, can't you? Yours doesn't. I haven't adjusted yet. I haven't adjusted. I think it also might be correct as voice too, so I might have to turn off our either try turning off our noise reduction plugin. Try yours now. Say throw it.
Throw it. Throw it.
I
Throw it.
threw it across the thoracic region.
Yes. The Theseus of the thorns said that I was the best boxer in the world. I Mike Tyson.
The cutting out is give me 1 second. Try turning off our will. Okay. Yes.
Odd bit freezing, if
A
you will.
tad bit frigid.
Nice, cool environment.
Okay.
Not too cool.
So now I'd like to point out that I did throw it across the thoracic region.
You threw it across the thoracic region,
Threw it and hit it right in the throat.
right in the throat. That is a good thing.
It is it's a theta thing.
Theta, the theta thing. Oh, that's good.
Turn it up. Okay. Jacob, I want you to talk for an extended period, talking about, all the
All the various things
theta
that
theta things and the
theta
thalamus, maybe.
things, theta, the thalamus.
Your
Oh,
thoughts on the
yes. One of the
thalamus?
things that I'll be talking about. And I think that it's one of the main components of our conscious experience. It's what allows for the taking segmentations of information and turning it into a complete coherent one whole. It's the integration process. Hence why there's a very large amount out of all of the systems, the thalamocortical system has the most integrated information, the most phi. And I think that's because it's the actual structuring, or at least the representation of the structuring process that we get for our conscious experience, what we perceive, our perceptions. And it's what allows us to relay that information to more higher order cortex functions that then relay back to the thalamus in this nice interdynamic process. Who knows the quantum processes that go on along that, you know? There's some interesting stuff. I think one day I'm gonna become a quantum neuroscientist. I think that's what I wanna be. Oh, that would be such an epic field. Quantum neuroscience. That just sounds cool. It's like taking the 2 hardest things and just meshing them together. Doesn't that sound just like a wonderful field to just completely dive into? I think it is. It is field the field of potential and rigorous mathematics for computations. Yes, turned into maybe we become biological quantum computers one day. That would be very well. Good. Very good. Test 1, 2, 3.
I adjusted yours to match mine, so we'll see if all the theta wave frequencies and the thoughts and the thingies,
The thingamajigs,
the thingamajigs,
thingathungs, be thugs. Theta Thugs. Oh, that would have been a good podcast name. Theta Thugs. I like it. Mm.
I feel like still cutting out.
Yeah, looks like cutting out.
Okay, I'm gonna do a monologue for a second, and then want you to do a monologue. Then we got to listen to it and then see how much of it actually cuts out. So,
Sweet.
um, so I didn't blank on anything to talk about. Um,
Talk about black holes.
so I was thinking exactly. I was wondering exactly the other day, like how realistic the whole idea, and you wouldn't know this because you hadn't seen Star Trek, but how realistic the idea of Vulcans are. And for your context, Vulcans are this race that is extremely logical, has has worked as a species, has worked progressively to um, basically suppress their emotions, like to the point that they don't factor into decision making. And as I was kind of learning about, and this would assume a similar brain anatomy um, to humans, but I was thinking about the function of the amygdala. The I don't know how realistic that would be for you to not have any emotions, if you could
Mm.
even operate in that way, or would you simply just shut down? Um, yes, emotions, I feel like in while I don't like them having a big impact on things in their essence, a lot of emotions are feel like they're connected to what motivates us to survive. What is going on? Here, let's try it again without my connection open to my computer
Okay.
and see what happens. Maybe it's that.
Perhaps.
Perhaps it's that. Perhaps not. Perhaps it's a nap.
There's an app for
So
that.
there's that.
Stream is
The cat in the
excellent.
hat came back.
Stream health is excellent.
It's a very healthy, happy stream. We are happy. We are healthy.
Happy all the time. Happy all the time.
Testing, testing, intermittent talking. See, that's okay. We're going to diagnose this thing with surgery.
Okay.
Here's what we're doing. We are going to turn off plugins until we find what is causing
What
that.
the issue is.
And if it's
Perfect.
not a plugin, that means that It is a connection issue. Like
Yeah, like it just said that the audio stream's current bitrate is 0.
that just means that's what YouTube's being fed, which means it's the audio portion of it was stopped, which means it could just be that there wasn't any audio to transmit,
Mm,
which could be a plugin thing.
okay. Zisvan. Then Zisvan. At least the audio sounds good when we got it.
Mm-hmm.
That's huge.
Okay, so I'm turning off both of our feedback filters. Things is it's going to prevent feedback. So they are now turned off. We can test and see if that was the issue.
We shall test and see if it goes away or if it doesn't, if we get a continuous stream of audio
Content.
and content, because that would be great because viewers like it when they can actually hear what we're saying to some degree.
So they are now turned. We can
Not that.
and see if that was the issue.
I'll test and see if it goes away or if we get a continuous stream of audio,
Content.
because that would be great because viewers like it when they can actually hear to some degree. Not that.
It's not that. Reverb. Testing. Let's see if it is this plugin. This plugin is one that is designed to remove reverb reflections from our voice because we are in a very hard room.
It is a very, very hard room filled with very, very hard men.
And lots of wood.
Lots of wood. Too much,
Way too much wood.
but
Way too much hardwood.
lots of bounce back on that wood.
Not that. Silk vocal.
Silk vocal.
Silk vocal is one that is designed to improve the silkiness and the smoothness and the quality of your voice.
Ooh, okay. Let's see if this is the one. I'm hoping so. That would be a very quick surgery.
Be very efficient, fast surgery, minimal complications.
That would be ideal. Nope.
Yeah.
F6. It's so weird because we didn't have this problem last time.
F6. This is F6 is a equalizer that is designed for specific. This one is specifically designed for live use, and so it should be able to handle this setting. But
Hopefully.
maybe not. Maybe there's something kind of screwed up in it. It's who knows? That was all of them.
Really?
Not a plugin?
Shoot. Is the connection?
Let me try. Okay, let me try just disabling on. There are a few things we have going on. We're setting
Hmm.
turn echo cancellation off.
Maybe. I'm hoping so. That would be ideal, especially since we don't have 3 microphones anymore. So weird, because this wasn't happening when we had 3 microphones, or I thought we had 3 microphones. Ever.
Echo cancellation is off. So let's see here what we got.
What do we
We
got?
got something that works. So if we got something that's cutting out.
Nope.
Testing now. Let's see if this fixes it. I don't know.
Perhaps it will.
Maybe not. Probably not.
Probably not.
I'm gonna have to go freaking put that dog up because that's annoying.
That is annoying. Probably for our Wi-Fi. Doesn't seem so.
No, it does not.
It is not fixing. We finally have good audio quality. And then it just it's like, no, your podcast would be too good. We're gonna have to make sure that snippets of it are cut out for legal purposes.
So let me see if it's. We know mine is, but let's check yours.
Okay.
So
Let's check here.
I want to see if it's a computer thing.
Perhaps. No, I don't think it is because mine was cutting out. It was doing the same thing as yours.
Makes me believe maybe it's my computer up there. That's maybe there's something conflicting over sound devices.
Potentially. Yeah. Yeah, both of ours are cutting out.
Okay, so let's last thing that I want to do here before checking that is I would like to test with all of the plugins off, period.
Mhm.
Maybe except for the ones that are on our individual microphones. We'll turn all the plugins off at the same time. Shut up.
Oh my goodness. Take a chill pill.
testing with all of the plugins off.
All of them off.
So it's probably going to sound pretty meh.
Raw, we'll say.
Mm-hmm.
But who knows? Maybe it'll fix all of our problems.
Might be able to. Who knows?
Maybe there was 2 different plugins conflicting with each other,
Could be.
but that probably wouldn't. Hmm, that wouldn't make sense. No. Well,
If
that's
this
that.
goes on much longer, I might need some methamphetamines or something.
Feta berries. Seriously. At that point, we just do the podcast in your room.
think do a speed. Which one? 5G? Yeah.
Mhm. Alrighty. I guess I should just continue to talk. I'm speaking. Don't speak. Don't speak. Don't speak. Oracly. It's not just decorative. Unique folds and curves act like a funnel, collecting sound waves from our environment and directing them into our auditory canal, or as most people refer to, the ear canal. I don't know what that sounds like. Okay. Yeah, that's pretty. That's it's definitely a very interesting sound. That's for sure. I don't know how to feel about that. It's very breaking up a little bit. This right here, these audio problems feel worse than a breakup. Genuinely, at least there's closure here. There's no closure. It's just open end. This narcissism on the system's part, in my opinion, you've done worse than breakup. You've destroyed me completely. Why have you done this to me? Oh, dude. Hello, hello, hello. How's it going? I'm going pretty well. Not really. I wish that these audio problems would go away. If they did, all of our lives would be fixed and we would have a great time. But instead, we're stuck here having a mediocre time fixing all of the issues that we always have. There's always a new issue here, but hey, always going to be prepared for the worst. So when we optimize our setup, then it's going to be all goody two shoes. Super good, super good, super great. I am very happy. I mean, I'm pretty content right now because, well, let's just say I am in an optimal state for podcasting. That's for sure. Even if the setup's not in an optimal state, at least I am. And I cannot wait to see what wonderful information we shall uncover today. I know there's a lot of information that's in my mind. I just can't exactly recall it. It's always the worst when you know you have a lot of information stored in your brain. It just takes very specific like cues in order to bring that information out into your consciousness to then verbalize it. It's quite the interesting process. I wish that I didn't have to rely on context in order to bring about information that I thought was relevant and interesting. It's quite a hassle, you know? I kinda wish I just had it all and organized nicely and I could just say anything I wanted, genuinely anything I wanted. One day, I will be able to do that, but that's not today, that's for sure. Although I did take some pramarisatam, which actually felt really nice. I've kind of been slacking in my taking pramarisatam because, well, kind of out, but there was a little bit left, and so I was like, "You know what?" I was able to put some into it, and honestly, it felt great. I had my acetylcholine, pramarisatam, I had some turmeric and ginger shots, and what else did I have? Quercetin. I don't know if I took my quercetin today. I hope I did because that stuff's really good for you. Uh, yeah, I did some research into so there's a pretty extensive and well-researched scientific basis for health longevity, and one of the most recurrent supplements that was, generally for health and longevity was quercetin, and so I thought that was really cool, and so I've been taking it every day, and I think it's actually been helping a lot. I think if I wasn't taking it, I would feel pretty gross, but I haven't gotten sick in a very long time, feel great. So I'm honestly pretty happy. I wish I could get some more sleep, but I'll be able to get a lot of sleep tomorrow. So I'm pretty excited about that. I'll be able to sleep in, and have a good time. Indeed. True. Oh, could be an upload issue. Okay. Ah, man. Okay. Shoot, an upload issue. That's terrible. How do we fix that? I don't know. I don't know how to fix that. Okay. I'm gonna listen to myself. Why is Test 1, 2, 3. I'm gonna continue talking. I hope when oh, that's very interesting. Hmm. Alrighty. I genuinely think we're good to go. Personally, this sounds great. The cuts are gone. When you don't listen to it live, you're alright. Now I think the viewers at home will be okay. It's just my phone. I'm pretty sure. At least I'm hoping it's my phone. If it's just my phone, then I think we're good to go. It sounds great up there, and when I rewind it and there's no internet issues, then it also sounds great. So that is a very good thing. Alright, I think we can go ahead and start with this podcast. It's time to get ready. Oh, shoot. Oh my goodness. Dude, I guess so. 'Cause look, listen to this. This is, like, right now. I was listening to it live. Yeah, I guess so. Yeah. I took off Wi-Fi and I listened to it just now and it sounded great. No, it's connected to the 5G. I'm pretty sure. I mean, unless it switched between the 2. Well, it might have been switching between the 2
Really?
because I've been both as my networks.
2G, the 2G would not have a good connection.
Yeah. Mhm.
So
Well, I mean, 9:30 is not a bad time to start, honestly. So
alrighty.
and plus, we were able to get rid of that, problem. I mean, genuinely,
Sounded really good.
it's yeah, and it's been going for an extended period of time now. I think this is the best we're gonna get. I think I'm really happy with this.
Probably the best we're gonna get right now without putting a bunch more.
Mm.
All right, guys. We are going to go to our starting student screen so we can kind of take a break and recoup and get ready for the podcast
Yep.
here and after all that headache, and then we'll be back. So we shall
You guys.
see you guys in a very short bit. Hey everyone, we are about to go live. We're going to do a quick check real fast to make sure that our audio is working still properly, given the fact that we seemed to have some audio issues last time, I think. So we're just making sure that everything sounds all peachy. And then we'll quickly cut back to our starting student screen and then get into it.
Oh, yeah. Let's do this.
So make sure that our mics are working properly. You got to test yours at the same time so we can make sure there's no feedback issues. So whenever Jacob has enough attention to focus on what I'm saying.
I'm all ears.
All right. Well, I need you to be all mouth and talk right now.
So I am talking.
Testing, testing,
Testing, one,
testing,
two, three.
testing.
Testing, 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 testing. Oh, yeah.
Pull it up on my phone. Let's see how it sounds.
Okay.
This doesn't sound. I feel like it's missing something from what it had before.
Hmm.
Maybe just the removal of the noise reduction. Testing, testing. 1, 2, 3.
Turn it on.
Turn it on.
We're turning it on.
Testing, testing. 1, 2, 3.
3, 1. Test. Stat. Stat.
The cat sat on the mat.
Yes. Who started swinging a bat and hit my ass?
Ooh.
That was that. Pretty kinky.
Mm. Turn it on. Okay, so you're turning that on. Add the clicks back into it.
Ooh.
That crap. I'm about to put that dog up. Testing, testing. 1, 2, 3.
Testing, testing. 1, 2, 3. Testing, 1, 2, 3. Testing, testing.
Testing. Not quite as full.
Yeah, there's kind of.
Wonder if we should turn our gains up a little bit.
Yeah, that'll probably be fine. Especially since there's literally no reverb at all. Good to do that.
So let's test this again. 1, 2,
1,
3.
2, 3, 4, 5, 6, 7, 8, 9, 10.
Cat on the mat. Smacked Jacob's ass.
With a bat. It was.
And the cat said it was fat.
Perfect. Perfect. I'm happy with that.
I think yours could probably still go up a little more.
Yeah.
Uh,
Let's go ahead and just try this real quick.
testing. Testing.
Testing.
The cat came back the very next day. The cat came back. He thought he was a goner.
Duck walked up to the lemonade stand and he said to the man running the stand, "Hey, womp womp womp. Got any grapes?" That's all I remember from that song.
No. But we do have shoes
And we have methylene blue.
and just regular math.
That as well. We got everything. I think that's great.
Sounds good. The one thing that I do want to do real fast is modify our curve, EQ curves a little bit.
Sweet.
A little more body.
Give it that nice summer bod, sexy body. Give them those Louis bodies. Your term. I was thinking like lewd bodies for a second.
Test. Test. Let's see if we have more body now.
Lewd body Alzheimer's.
Any lewd bodies out there?
We got two right here.
Mm. Yeah. Let's try that. Now that we have a little bit expanded low end, I think we might have a little more
Lewd body.
lewd body.
Yes, we need more lewd.
Not sure what I'm doing here with this, but a little more,
Neuron activation. I'm saying.
There's still something about yours.
It's yeah, it sounds looky robotic.
It does sound a little robotic.
I don't know why. It was good a bit ago.
How's your connection? Like,
It says excellent.
oh,
So I'm not exactly sure. But that doesn't sound robotic.
let me try.
All right.
Bear with being so picky.
No, we're chilling. I already told my mom I'd be home pretty late.
Oh,
Hmm?
back. Brush. Talk for a second.
Hello, hello.
Talking,
I'm
talking,
talking.
talking.
I'm talking.
He's talking.
Yes, we're talking a
I'm
whole lot.
talking. I'm talking.
It was worth it was
And it was good.
worth it though, because it sounds so much better. Oh yeah.
Indeed. I think it's when we're both talking together and one of us is quieter than the other one.
Mm.
That it,
Yeah, I think so.
let me bring yours
Understand.
mine threshold
Fresh.
down
Oh,
the that was you try talking now. Let's
okay.
see how yours sounds, if yours sounds any better.
Let's see if this sounds any better at all. I'm hoping that it does. I think it will. I'm very hopeful, very positive. And if it's not, then oh well, it is what it is. Name of the game, man. We still game is the name. Name game. Game game. Yes. Test. 1, 2, 3. Hello. Test. 1, 2, 3. Um,
There's something going on with your
yes,
microphone that I cannot put my finger on. I wonder if I can fix it by turning off something. Your video ninja setting, maybe.
potentially.
Don't know. It's gonna bug me because it sounds slightly degraded.
Yeah. It's like what is degrading it? Where are they? Sorry, I made them invisible. I said, disappear, and it listened. I was like, shoot, I have superpowers. Who would have guessed? I actually have telepathy.
Let's try that. Say something nice.
See something nice? You are beautiful.
Oh, stop it.
You really do have those lewd bodies
Oh,
in your basement.
okay.
I know. I've been an undercover cop this entire time. We are here to arrest you.
That's not nice.
Sorry, but all in good things. Uh, I mean, I like that better.
Try it now. I've turned your voice isolation on. So maybe
Okay.
who knows?
Yeah, actually. Okay. So my voice is now isolated and ready to go, ready to rumble.
His voice is in prison.
Yes, imprisoned. Why am I the one in jail? It should be you. Dang it. Probably both of us should be in jail at this point. Maybe we take over the jail system and we run it ourselves.
Sounds bad.
Yeah, I'm genuinely happy with that.
So to do some work on your mic, like with it being here, like if you leave it here, like to be able to do some work on your EQing because there is something slightly off.
Yeah. Mm-hmm. Yeah, I'll leave it here.
Actually, here, let me try this real fast. Say something at a similar level to this.
Say something at a similar level to this.
Okay, I think your gain might still be slightly lower. Um, try pushing it up slightly.
You know? All right. All right. Okay. Here we go. Testing. 1, 2, 3. My gain is a little bit higher. We're going to see if that fixes anything. Hopefully it does.
Testing, testing.
Testing. I like it. That did actually sound better.
Yeah. Okay, we'll stick with that for now.
Sweet.
I'm gonna
Go ahead and start.
do some work on that though later because audio is one of those things that really I get really particular about because I know because of all the work that I've done with audio
Mhm.
over the years and the detailed analysis work, I've gotten really my ears have gotten really attuned to picking up like the things that shouldn't be there or that should be changed.
Yeah.
And so
Mhm.
it's not like it annoys me, like it's like grating on me to hear it, but it bugs me in the same way that like something being unfinished might bug somebody, you know? Um, like say somebody had a OCD about like it could never leave a puzzle unfinished on the table or something like that, you know?
Mhm.
That's how it is for me. It's like it's unfinished, like it needs to be there's something that needs to be adjusted there and in order to make it
Yeah.
sound optimal.
I think for my credentials, I'm gonna add.
Hang on, we haven't switched back to our voting screen yet.
Hello, welcome to ThetaWave. My name is Jacob. I am a neuroscience researcher with a background in evolutionary biology, and I am here with my co-host Ryan Weed.
Ryan Weed. That is a first. I've never been called that before.
Yes, Ryan Weed. Okay, just kidding.
Ryan Weed.
So, can we restart that?
Sure.
Ugh.
All right, guys, we'll be back.
With the tongue on the back of the teeth.
Give
Come
us a second to reset here.
Hello and welcome to ThetaWave. My name is Jacob. I am a neuroscience researcher with a background in evolutionary biology, here with my co-host Ryan Reed. He is a neuroscience researcher, machine learning engineer, singer, songwriter, and a very close friend of mine. So, Ryan, what have we got going on today?
Well, today we've got quite a few fascinating topics that we're going to be covering, as well as
Ooh.
hopefully a little bit of free flow. We've got
so.
Dihexa as our nootropic topic.
Nice.
And we have activation functions that I'm going to be going over. And I believe the auditory cortex.
Yep, we're going to be going over the auditory system, so the pathway and the cortex,
Nice.
those interactions. It's going to be interesting.
Yeah.
Sure. I'm also curious to learn about activation functions because those seem fairly relevant.
Yes,
to some degree.
they are. Well, they do have a specific relevance
Yeah.
to neuroscience because they were, in a lot of ways, they were inspired by and based off of some of the functionalities of neurons. And as you'll see, once we talk about them, go over them, they are largely what make possible our modern day deep learning.
Interesting. Okay, that's actually really good because a lot of times I think people get confused that machine learning is completely different from neuroscience, when in reality those two sciences help each other progress. And so that'd be a really cool correlation to kind of show the viewers.
Yeah.
All
One of
right.
the reasons why I chose to kind of study those two in tandem with each other, that there's a lot of overlap and there's a lot of there's a lot of overlap, but there's not so much overlap that it makes it pointless to study the other area. There's like enough difference there that it can makes having the other area as a reference useful,
Mhm.
kind of a similar field of knowledge that you can pull from easily with,
Yes.
as the more advanced you get into
Mhm.
the other field. So like the more I learn about machine learning, having something that's similar enough that I can pull from it, but is also its own thing, that I build up at a similar time and level
Yeah.
helps me try and think about things maybe from a little bit of a different perspective or give supplementary knowledge.
Oh, definitely, for sure. I definitely think the same way. All right, so want me to go ahead and start?
Yeah, yeah.
All right, perfect. So I kind of want to start off with kind of an open air question, literally. So one of the things we need to think about is how do very simple vibrations in the air become the music we love, like the voices we recognize, or even some of the warning sounds that keep us safe, that twig snapping in the forest. And so let's kind of explore the architecture a little bit.
Yeah, it's the vibration of air molecules causing frequency generation and hitting our eardrums.
Hmm. Yep. And what it hits first is the outer ear, and it's also called the pinna or the auricle. And it's not just this nice, beautiful decoration. It has unique folds and curves that act like a funnel, collecting the sound waves from our environment and directing them into the ear canal. But it's also known as the auditory canal as well. And it's not just a tube, it slightly amplifies certain frequencies through resonance and leads sound waves inwards towards the middle ear. And so at the end of the ear canal lies the eardrum. And if you want a little more of a technical term, it's also called the tympanic membrane. And it's very thin, taut, and it vibrates when sound waves hit it. And these vibrations are tiny, especially for faint sounds, and they need a boost. And so that's kind of that job of the eardrum, is to give it that nice little boost at the beginning.
Which is fascinating because that's also how the um or what are they called? Um Blanking on
The
hold on a second. It's the component within microphones such as the Blue Yeti,
Oh, yeah.
high quality recording microphones that makes actually making digital signals out of audio possible
Oh.
because it works in a similar way.
Mhm.
It basically it's like very thin material within it that will vibrate and resonate and it basically as a kind of works as a capacitor. And the closer it gets to uh, the base plate,
Mhm. Yeah.
the more electrical signal it generates as it vibrates, and so it creates this small low level signal that then has to be amplified. So it has to go through an amplifier
Yeah.
as well as a filtering and whatnot.
Mhm. That actually kind of leads into kind of the next area of what I'm gonna talk about, which are kind of these bones and that are connected to the inner surface of the eardrum. And they're called the meniscal bones, and there are 3 of them, and they are the smallest bones in the human body. But that does not mean that they're the most irrelevant, that's for sure. So there's the malleus, the incus, and the stapes. And collectively, they're called the ossicles. And so they the malleus is attached to the eardrum, and the incus kind of acts as a bridge, and the stapes connects to a small window leading into the inner ear, called the oval window. And these bones act as a lever system,
A
as
lover system.
Mhm.
So
So
they're lovers?
kind of. It's a good analogy. It's like as the eardrum vibrates, it moves
Passionate, intimate lovers?
passionate. passionately moves the malleus.
So
Which
a
then
lever system,
Yeah.
not a lover.
Yeah, a lever system. Sorry.
I heard lover when you said it.
Oh, a lever?
Yeah.
Yeah. So it's a lever system, moves the malleus, which moves the incus, which pushes the stapes against the oval window. And this kind of serves the two crucial purposes of amplification, so increases the force of the vibrations, and impedance matching. And so, like impedance matching, yes. So sound travels easily through the air, but less easily through the fluid-filled inner ear. And so the concentration of force from the larger eardrum onto the much smaller oval window by the ossicles helps overcome the difference by ensuring that efficient energy transfer. And also in the middle ear, before we get to the inner ear, is the Eustachian tube. And so it actually connects to the back of the throat, and it helps equalize air pressure on both sides of the eardrum, which I think is really fascinating because that's why yawning or swallowing can help pop your ears when changing altitude. That's because of the Eustachian tube.
Interesting.
It helps equalize air pressure. It's cool. So
Fascinating that there's almost a mechanical, mechanistic method by which the body has been able to achieve amplification in the same way that some of our really complex circuits, like that we have to carefully, design, and that have taken us years to refine and be able to build, like, and the way that those things achieve it through a really, really tiny
Oh, yeah.
complex series of events,
Mhm.
it's fascinating that the body was able, because normally mechanical, you can't achieve intricate um such intricate processes and goals through mechanical move, like, what do you call it? Like, almost meta mechanical movement.
Mhm.
Um, so it's interesting that that's actually a mechanical, the
Yeah.
the amplification, if I understood that correctly, was mechanical.
Mhm. Yes, definitely. Which is it really is cool, And so after that kind of amplification process, we kind of reach kind of the inner ear, and it's home to the cochlea, which is the organ of hearing. And it's kind of shaped like a tiny snail shell, and it's filled with fluid and contains incredibly delicate structures that convert those mechanical vibrations into the actual electrical nerve signals. And this is the process called transduction.
Mm.
And so when the stapes pushes on the oval window, it creates pressure waves within the cochlear fluid. And inside the cochlea is a crucial structure called the basilar membrane. And this membrane is remarkable. It's narrow and stiff, which is also called the base, and gradually becomes wider and more flexible towards what is called the inner tip or the apex. And so what's important here is to remember that there's the base and then the apex, which becomes stiff and then flexible, more flexible and wider towards the apex. And so this graded structure means different parts of the basilar membrane vibrate maximally in response to different sound frequencies. So like high frequency sounds cause vibrations near the base, and low frequency sounds travel further down and cause vibrations near the apex. And this frequency to place mapping is called tonotopy, and it's a fundamental organizing principle throughout the auditory system, and will play a role in other systems as well. So the
What was
rest
that last part about tonotopy?
of tonotopy, it's that fundamental organizing principle of auditory
Okay.
information that is also used in the cortex, and not just the ear. So on top of the basilar membrane, based in the apex, is the organ of cortici or corti. Corti? The organ of Corti, sorry. And this is where the sensory receptor cells, the hair cells, that's where these reside. And there are two types. So they're the inner hair cells and the outer hair cells. Very complicated names, I know. And as the basilar membrane vibrates, it causes a shearing motion against other overlying membrane, the other overlying membrane, which is the tectoral membrane, and bends the tiny hair like stereocilia that is on top of the hair cells. And so this bending is kind of the spark, the moment that opens the ion channels in the hair cells,
Mm.
causing electrical changes. And then the inner hair
So
cells. Yeah.
the movement changes electric potential and the
Yeah.
uh the like membrane potential and whatnot, and thus
Mhm.
results in potential firing.
Yes. Yep. So that's when, those electrical changes happen. And so we have first the inner hair cells, and these are the primary sensory transducers. They release glutamate when stimulated, and these activate the auditory nerve fibers. And then the outer cells kind of act more like amplifiers, actively contracting and relaxing to sharpen the tuning of the basilar membrane and increase sensitivity to soft and minute sounds.
Mm.
And damage to these hair cells, often from loud noises or aging, is usually the most common factor when it comes to hearing loss. So let's talk about the auditory nerve.
Mhm.
So the electrical signals generated by the inner hair cells are picked up by the fibers of the auditory nerve, which is also known as the cochlear nerve or the cranial nerve 8. And each fiber connects just one or a few inner hair cells and carries information about specific frequencies and intensity towards the brainstem. And so it's like a good metaphor is like a bundle of frequency specific telephone lines that are all headed downtown to that brainstem. And the auditory fibers make their first connection in the cochlear nuclei located in the brainstem. And at the junction, and so it's kind of at the junction of the pons and the medulla. And here the information stream begins to diverge and gets processed initially. And different cell types in the cochlear nuclei extract different features from the signal.
I don't know what the cochlear nuclei is, so that doesn't
The
help me much.
the cochlear nuclei is is where that um, initial auditory information gets processed and then split to then go to its or that's where it ends, or that's where it starts, and then ends up getting kind of split into where it's going to go next.
Okay.
So it's that initial processing location. And so, yeah, and then there are different cell types that extract, it's that feature extraction from the signal. And so like the onset of sound or like the changes in frequency, those all get specifically extracted in the cochlear nuclei. And then the pathway becomes a little more complex, involving multiple parallel routes and crossings. So a key early processing center is the superior olivary complex. I'm going to call it the SOC for short. And it's also one of the other key early
Olivary?
processing centers. Yeah, olivary complex. And there's also some processing done initially in the pons. But the SOC is crucial because it's the first place in the pathway to receive input from both ears. So it has this two-ear binaural information that is essential for the sound localization process, which is kind of figuring out where a sound is coming from. And from a survival perspective, that is probably one of the most important
So it's
features.
the combination of the nexus point for the two signals.
Mhm.
Interesting.
Exactly. And so without this feature, we wouldn't be able to know and detect which sound is coming from. Because we hear a sound from over here, you know to look over there. But if this process wasn't happening, then when you hear that twig snap in the woods from somebody from from a predator hunting you, you might just simply run in that direction because you heard a sound, you're just running, you'll meet it right there. But this helps us localize sound in which direction we need to go to. So, yeah. And then it also
5.1 Dolby Surround.
ooh, ooh, ooh,
Feel everything.
exactly. It kind of takes advantage of this from our ability to localize sound. And then, it also compares like tiny differences in the arrival time of sounds, as well as like the intensity of sounds reaching both ears. And then the signals start to ascend via a major fiber tract called the lateral lemniscus. to reach the inferior colliculus in the midbrain. And the inferior colliculus is a major integration center for auditory information. It combines frequency information with the localization information from the SOC and then maps the auditory space, then integrates information related kind of to like a startle reflex, hearing that initial sound, and plays a role in filtering the self-generated sounds like your own voice, which is really cool that that filtering process of your own voice happens there. It's why when you listen to your own voice from an audio recording, you're gonna be like, "Oh my gosh, why do I sound like that? That's terrible. That's not exactly how I sound." When that actually is how you sound. It's just your brain filters your own voice differently than other noise. And so let's talk a little bit about the thalamus. All Pretty much all of the sensory information heading to the cortex makes a stop at the thalamus first. And hearing is obviously no exception. Auditory information from the inferior colliculus travels to the medial geniculate nucleus of the thalamus, which acts as the crucial auditory relay station. But it's more than that. You know, it further processes auditory signals, it integrates the information, and plays one of the roles in directing the auditory information and gates the flow of information to the cortex. And that's where we're kind of gonna end this whole thing is the auditory cortex. The auditory information arrives there, and the auditory cortex, it's located in primarily in the temporal lobe of the brain, and it's kind of tucked into a fold. It's called the Sylvian fissure, but that's not really that important. Just know that it's located in the temporal lobe. And so we have the primary auditory cortex, and we also call that A1. It's also known as Hetschel's gyrus, and A1, it's kind of topically organized, right? So neurons that are responding to those specific frequencies and then arranged in an orderly map of those frequencies. And it's kind of what's essential for that fundamental perception of sound and kind of detecting kind of the pitch, the loudness, and the timing of sounds. And damage here can really cause difficulties in kind of the more like basic sound features. Though if kind of the earlier processes in the auditory pathway are intact, you still have some hearing. So it's not complete loss, but the majority of it is because that's where that initial fundamental sounds are going to be processed, which then is further processed by kind of the secondary auditory areas and association areas. And so for like interpreting complex sounds, like recognizing melodies, like the differences in different instruments and environmental sounds, as well as like speech perception, like the Wernicke's area for understanding complex language. That's also going to be there, like integrating that auditory and language function. And so it's like decoding those complex patterns for spoken language, and as well as and there's also more sound localization processes being done. That initial localization being done in the brainstem that then gets further refined in these association areas. And as well as that's where kind of process as well, like remembering somebody's voice. And so, yeah, and also integrating other senses in relation to other senses, like
Sight,
seeing,
sound, and
yeah, like recognizing.
Oh, I recognize this
noises.
person. The sound of this person grates on my nerve, and their smell is terrible.
Exactly, just like that. Yeah. So, and so it's also just not like a one-way street that goes from the brainstem to the thalamus to the auditory cortex. There are extensive descending pathways. So there's ascending pathways and descending pathways running from the cortex back down to the thalamus and in the midbrain and even in the cochlea itself. So, which then influence the connections to the inner hair cells. So these feedback loops kind of allow the brain to then like continue to modulate auditory input and for just a little bit more of some good dynamicism there. And so it's able to help us, focus on our attention on like specific noise or a specific voice in a noisy room. Like imagine this room was filled with a lot of music and other people talking and chattering. This kind of descending pathway that then integrates back into the cochlea allows us to then fine-tune what information we really want to focus on and recognizing those speech patterns to then initially be able to fully focus on that voice even in a high, noise environment. So those
Attention
those
mechanisms.
feedback are very important for auditory specific,
Is that attention part of the attention
yes,
mechanism?
for sure, for sure. And so, yeah. So from the simple collection of sound waves by the pinea, the outer ear, and through the mechanical amplification in the middle ear, and then the transduction by the hair cells in the cochlea, and culminating all of these complex interpretations within the auditory cortex.
Apparently, I just looked it up for the sake of clarification, because I know a lot of these are words that we read and don't say out loud.
Sure.
And so sometimes like the pronunciation like is never formed, but it's apparently it's cachlea.
Cochlea,
Yeah.
not cochlea.
No.
That is the lectures that I watched. The dude doing the lectures said cochlea,
Really?
cachlea. Interesting. Okay, yeah, that
That's what it
makes
says.
sense.
Says here, I looked it up. It's spelled Cochlea, right?
Yeah.
Yeah, because that's where the origin word is of cochlear,
Ah,
right? Like
yeah.
the um, what do you call that?
What?
I'm blanking on them,
Oh,
but yeah, apparently it's
cachlea. Well, so
it's cachlea.
cachlea. Sorry about that, guys. I accidentally got the name of that wrong, but
And to be fair to you, I've always heard people say cochlear, so
yeah,
it would make more sense for that to say or for that to be cochlea.
just slightly. But, it is what it is, I guess. But yeah, that's pretty much everything you need to know about the basics of the auditory system.
Oh, it is cochlea.
It is cochlea.
Yeah, it's just spelled here like the way that
Oh,
they showed or told you how to pronounce it here is spelled with um like spelled
see.
as in cachlea. Like it's
Oh,
weird.
so I was right. I wasn't wrong,
You were right. Yeah.
theoretically. Okay, sweet. And there's probably multiple people who call it different things. Like, there's probably some people who actually do call it the cochlea and the cochlea. It's just
I just got confused
yeah.
because I heard you switched between pronunciations there briefly, like the cochlea
Oh,
and uh, cochlea and cochlea is
oh,
what you
yeah.
said. And then so
Whoops.
I was like, which one of those like is the right way to pronounce it?
Neither. We're both.
No, yours was
Yeah.
your initial one was right.
Okay, okay, that's
Cochlea
good.
was right.
Well, now that we understand which is the right way of pronouncing it,
Cochlea.
cochlea. Now we know. Now we really know.
Everybody needs a cochlea in their life.
That's for sure. Otherwise, you won't be able to hear at all.
Mhm.
So, all right, that's it. And so,
That was
how
a
you agree with that?
truckload.
It was definitely a truckload. It's kind of sad because it's one of those systems in a brain that don't get a lot of attention, which is
Mhm.
really sad. Even though it's really important. Like if you're deaf, that kind of causes a lot of problems for you in life. And it's actually one of, if you were to combine all of the papers of all the different senses, the auditory system is actually one of the least researched areas of the brain.
Interestingly, it's also one of the uh, least researched areas of data science as well.
Mm.
I specialize in audio analysis, or did for years, and specifically human voice analysis as well as human hearing analysis, which interestingly there's a different form. You know how like normal loudness is measured in decibels, right?
Yeah.
There's a different form of measurement that's more accurate to how humans hear
Mm.
things, the loudness. So decibels isn't actually accurate to how humans hear. The form that we use for how people hear is pascals.
Oh, I've that sounds really familiar.
And so there's a couple people that have done a lot of basically done the majority of like the legwork in researching those fields and bringing them along. Um, but they are surprisingly um,
Undeveloped,
developed
underdeveloped.
and
Yeah.
untapped. Yeah.
Mhm.
Um,
Well, hopefully, this little section here, people will listen to this and be like, "Huh, now that's really interesting. I want to do some research into this." You know, we need more auditory neuroscientists and data scientists,
yeah.
apparently. So
I don't mind being one of the only ones.
yeah, that's true. It's kind of cool. You know, it's kind of like your thing now.
Well, yeah, it just gives me something a little bit unique.
Hmm. Not everyone can be unique. Hopefully not.
Depends on how you define unique, which could get into an
Yeah.
entire philosophical discussion because is anyone really unique? Like,
No, I mean, that's actually very interesting, you know, because 99% of our genetics are the same. But that 1% has such high levels of variation that our uniqueness is quite literally off the charts.
Mhm.
It's pretty incredible, but it's
But when we scale the amount of unique factors that we have to the amount of ununique factors that we have, the unique factors become pretty much invisible in that scale.
to some degree, you know, I would say that's why a lot of people feel the need to express themselves as an individual and in their own way because they are so similar and have such similar experiences to most people, even if there is that slight variation there.
Now, if we take into account the developmental differences that occur over time, and then we delve in so deep that we get to the exact structuring and weights of the neurons in people's brains, on that scale, I think factor, their unique factor would way outweigh the overlap factor. Um, because of the fact that environmental circumstances, memories,
Mhm.
experiences, values, people around us, all that stuff all goes into adjusting those networks. And so, in order to come out exactly the same as somebody else, you would literally have to have the exact same circumstances,
It's
which is going to be,
impossible.
for all intents and purposes, impossible.
And, you know, it's really interesting. Even if you were standing right next to somebody for their entire life and both experienced the exact same things, had the exact same genetics, the even the slight deviation and difference of perspectives would cause a
Oh yeah,
different
like you're both walking
neural
down the street
structuring pattern.
together, and then one of you happens to get clipped by a car because you're on one side.
Mhm,
You're
exactly. So
slightly
there's
offset.
so many different and, you know, you make a really good point. There's such, high levels of dynamicism within the brain. I mean, I like to say, I always tell people 20% genetics, 80% experience. Who cares if 99% of our genetics are the same when the 80%, the majority of what we're made up of, our experiences,
Mhm,
are the determining factor when it comes to who we are.
mhm.
So in that aspect, you are completely unique.
And that's a very, very hard field to uh, quantify and research because I was looking
Yep.
into the research recently of people's personalities and how much of that is initially genetically determined, or rather, um, and this was my hypothesis going into it, was that genetics set an initial stage, but then our experiences and circumstances
Mhm.
uh, determine the actual story that
Yeah.
plays out, um, and the shape that that kind of takes. And the so I was looking to try and determine how much genetics actually factor into
Mhm.
people and how they turn out, and kind of the main traits that they end up with. And um, there's some interesting research that's been done, but it's very hard to do, because the best scenario that they can basically come up with to determine that is by taking genetically identical twins that grew up in entirely different circumstances, which is a
Yeah.
rarity. And
Mhm.
um, then looking at the traits that they share and then the traits that they don't. And even that is prone to a lot of different flaws,
Mhm.
such as commonalities amongst the culture,
Yeah.
um, you know, random overlap, and and a whole host of other factors that could influence that. Like you could have had similar parents with similar
Mhm.
values that ended up, and those values end up, kind of
Yeah.
having a high likelihood of instilling certain traits, into, and so it becomes a very muddy thing, especially without a large sample size. Like if you were going to do that kind of a study,
Yeah.
you would need identical twins that grew up in separate environments to be a whole lot more common than they are.
Yeah. I mean, I find a lot of it, like if we could do this on like a mass scale, I find the most important thing to be, well, let's find the overlap in the initial beginning gene expressions that then get shaped by environments. Which ones get turned off based off of those experiences, you know?
Yeah,
That
we would almost need a little bit more correlation to
Mhm.
underlying
Yeah.
genes.
And like, did the twins that get separated, did they get fed by breast milk, or did they get something else? Like a baby formula. That's also going to have a
Mhm.
mainstream play when it comes to the nutritional value of how they
Did they
develop.
grow up in a stressful, contentious home? Did they grow
Mhm.
up in a peaceful, loving home? Like
Exactly.
there is so many different environmental details that even early on can set the course for some of those traits that develop later on.
Mhm.
Even being like an only child, like
Yeah.
if you're adopted as an only child, that can have an influence. Like,
Oh, for sure.
so,
Mhm.
you need more data on the genes to be watching, and how
Oh, for
those
sure.
interact with
Mhm.
developmental changes, and
Yeah.
almost like tracking things over time,
I
like
I think
genes over time,
I think the biggest mistake that we've made is doing this on humans. you know, especially because out of every single species there is, we are the most malleable. If there was a way to quantify like
neuroplasticity for
animal
the win.
exactly. If we were able to quantify perhaps animal personality and have them be identical twins in different environments, something that's more fixated on the specific genes of those identical twins, that would probably lead
We
to a
should
better
do.
understanding
Oh,
of
you
it.
know what we should actually do? We should
It's hard to do though.
we should take an animal that has a high personality expression. I don't know, maybe that could be.
Well,
Hang on. Let me finish this. Maybe it could be something like dogs. I don't know if there's a better animal to do it with, but then you should clone them. You giggle, but I'm serious. You should
let's
clone
do it.
them, and like a bunch of different times, give them like different circumstances,
Yeah.
and then raise them and see how, and track the genetics, their
Mhm.
genetics and their behavioral differences,
Yeah.
and see what kind of, and that will give you an idea for that species. That's not necessarily going to translate into humans, because of
Yeah.
the fact that we have a lot more complexity to our personalities,
Mhm.
as well as our cognitive development. And but it would give us a little bit of a deeper understanding of that
Mhm.
interplay that happens.
Yeah, because there are those intrinsic organizing principles that relate to fundamentals of genetic expression. And if we're able to map those, even if it's not in humans, that could give us a really key insight into how evolution has decided to structure this process, you know? I mean, that's really the key here, you know? Like, when Mendelian genetics first got, um, really popularized because his work was discovered, it was done in pea plants, and the main critique was like, "There's no way that pea plants
Pea
are
pants?
going to correlate with how genes, are passed down through generations for something like organisms or humans," when that was just completely wrong. It's just the complexity of the organizing structure just increased, as opposed to did something different from these very simple genetic organizing principles,
Mm.
you know?
There's a component of personalities that is because they noticed one of the things they noticed in their study of twins, or the couple studies of twins that they've done, that were raised separately, is that there are certain traits, such as those exhibited by um, the more, I guess, what would be considered the more socially dominant personalities, such as the
Mhm.
Enneagram 8,
Yeah.
that really needs to kind of control and protect, his flock and that kind of thing. There are certain personalities that are likely to have a greater influence come from genetics,
Oh, yeah.
such as that one. Like that one tends to a lot of it tends to be influenced. A lot of its development tends to be influenced by
Yeah.
genetic,
Mhm.
and that's to me is interesting because it begs the question: are those caused by adaptive changes made as a result of trauma, or hardship or something like that experienced generationally, down back down the line by somebody that then passed it on in their genes as a important component because in their experience was what was needed to
Mhm.
survive was these traits. So it's like, let me pass these on
Yeah.
down to my children
Mhm.
so that they can survive. And and because I know that like my dad, who's an 8, he like a lot of his personality that he developed into and his who he is was influenced by his kind of rough and unsafe
Yeah.
upbringing.
Mhm.
And so it would be easy to see how that kind of thing, especially if it happened multiple times, like in a like for multiple generations, like one person developed a 8 personality because of trauma, then the next one developed an 8 personality because of trauma, um, but not necessarily just
Mhm.
solely because of the gene, but because of circumstances too. So
Yeah.
those environmental circumstances are like reinforcing
Yeah.
those gene behaviors,
Mhm.
behavioral changes, and then that ends up getting passed down to have higher and higher likelihood
Yeah.
of resulting in more and more visceral effect, on
Mhm.
the children.
Oh, for sure. I mean, a very simple example of this would be something like aggression. Aggression is something that is intrinsically encoded within us, not something that is formed by environment. What is formed by environment is the accentuation or inhibition of that process, and that becomes epigenetic at that point, where the initial primary responses are quite foundational, but then the accentuation or connections between the inhibition processes are what allows those more complex personality types through environments to develop, you know?
Mhm.
So,
That'd be interesting. I could very well see there being somebody that was born with a uh, higher likelihood of aggression, genetically, but then through some sort of, whether it be defect in genetics or defect in through environmental changes, um, if their mechanism for causing those epigenetic changes to dial down or up certain behaviors was inhibited,
Mhm.
that would result in somebody that was naturally and uncontrollably more prone to aggression
Yeah. Mhm.
than normal people are.
Yeah. So what you're saying is through different factors of different mutations, whether it's an active, like actual genetic mutation or environmental factors at play and accentuating or inhibiting that causes. Um, are you talking about how they would then respond?
I'm talking about how that could cause as an outcome, an individual that would um, have no ability to change that portion
Mhm.
of their behavior. Like they would always have higher aggression. And because of that, because that happened to be inhibited, those epigenetic abilities to change that happen to be inhibited, whether it be again like
Mhm.
genetic or environmental. Um, the There would be those rare cases in which you'd have just this individual that was seemingly inexplicably just incredibly violent, and
Mhm.
like that makes me just brings to mind the fact that like oftentimes we kind of balk at things like serial killers and whatnot, and people that are like um just seem to have something really messed up and wrong
Mhm.
with them, and like we call them evil and yada yada yada, and sure, like what they're doing is like terrible, but that's kind of where my whole I don't generally blame people for like the things that they do, because they are who they are and they were dealt the cards that they were dealt, and they couldn't control that. And in a similar way, these people, they don't they aren't free of responsibility for their actions,
Mhm.
but they um are we can still be understanding of their situation, because we we don't control the circumstances that we're dealt in the environments that we grow up in. We just run with the cards that we're
Mhm.
given, and sometimes that's a messed up hand,
Very much so.
um and so with that understanding, I feel like maybe eventually, if we get to the point where we understand genetics enough to be able to do this, there can be, in situations like that with a serial killer, there can be an actual diagnostic done of like
Yeah.
what it is that
Mhm.
happened that's causing the lack of
Yeah.
ability to control
Mhm.
these really unhealthy societal behaviors that normally people can auto control by themselves,
Mhm.
and then figure out how to give them back that ability and let them make the choices they need to
Yeah.
make to change that from then on out.
Mhm. And if anybody listening to this is skeptical of this perspective, I just want you to go ahead and look up brain scans of serial killers versus a normal functioning human being. And this will enlighten you and make you understand why this is the correct way of viewing it because they are sick,
Mhm.
literally neurologically sick. And the amount of neurons they have dramatically decreased. It's instead of these nice plump formations of different gyri and different connections, that's it's lessened, more smooth, smaller, and this is why they're not able to live normally like us, and some of that, it's kind of like back to, like, the nature versus nurture, and is that their nature? Is their neurological disorders simply how they were born? Some of the times, maybe there are some genuine problems with
Mhm.
their, genetic disposition, but a lot of the times, it's because there was complete lack of correct nutrient dense environments, both for how they should learn how to behave
Both physically,
and
emotionally, yeah,
physically, emotionally, mentally,
socially.
socially. Yes, the majority of it is social. I would say to some degree. I think a lot of like the
Well,
issues.
the reason that we build up values that allow us to
Mhm,
adapt to social environments is because of experiencing in social environments in which we see value.
yeah,
If
mhm,
we don't see value in a social environment, why would we learn to develop traits that help
exactly.
us navigate it?
And even sociopaths uh, understand the value of social traits and are able to navigate it actually surprisingly well, scarily well. And we like to think of sociopaths as these like killers, but the majority of
That's
them,
different. That's a psychopath.
yeah,
Sociopaths are not.
yeah, exactly. They're
They tend to be
they tend to be
narcissistic,
narcissistic,
but
but fairly integrative within society, and so there's the majority of how we learn to interact with the environment in a successfully uh, or a socially successful way is through those initial values that we get from the people around us. And, if you have terrible parents, terrible environment, terrible food, terrible friends, uh, not you don't get access to healthcare, to the medicines, to the herbs that are needed, and you're not connected with nature at all. There's no out. You're gonna make an out, and the out that comes from those primal instincts is one of aggression and
yeah.
fear. Not and through that, you're gonna have
And
this.
developing those networks, and those are the ones that are going to
Yeah,
reign supreme. And with
mhm,
that comes a propagation of those outcomes and behaviors because, like, whenever like violence begets violence, which begets fear, and like, all these other things that tend to happen, the more that those happen, it's
mhm,
like this negative feedback loop
yeah,
where um I punch you, then you punch me, and then I'm afraid of you punching me again, so I punch you back, and you're afraid of
mhm,
me punching you, so punch me, like,
yeah, and then it starts to become only about control and feeling.
survival too.
Yeah,
Yeah.
survival, you mainly do that by,
Control, like,
yeah,
it
controlling your
helps with
environment.
survival. Yeah.
Mhm, and so you start to slowly try to convince yourself that you're in control of everything, and so, like, a lot of the times, event maybe at the beginning, you feel like you're in control of nothing, and so you try to dominate by killing an animal, let's say. You find a lizard, you squash it. Like, "Yeah,
It
that's
all
me."
starts with that lizard.
Starts with that lizard, squashing that lizard. Then maybe a frog, then maybe you find a rabbit and start, really just you strangle it, because there's these primal urges of aggression that start to manifest and start to give you finally the purpose that you've been longing for. And then you can
I'm not
also.
sure I'm a fan of the way that you specified strangling a rabbit.
I mean, that's I would say there's been many serial killers who have strangled rabbits, personally. But,
Personally, you've known them?
yeah, I talked to them,
Okay.
but they also say that it's more thrilling to go humans, right? Because what they do, it's actually very interesting because, even though their social processes are a little bit, obviously deformed, they can still see the intrinsic values that other people hold, and actually going against that and then fully conforming it to their perverted, fundamentally neurologically perverted, ways of navigating the world, conforming them to that standard is their way of expressing that control. And then eventually that can get even more complex through, saying that they did these for specific reasons, and you have these, manifestos, and then they want to be publicized. They want to start to express that perverted desire into the world, and that's how you kind of get these very interesting stories. And Netflix done a great job of promoting these types of people. So it's wonderful.
Um, the if you think about their actual behavior, the only reason that it seems so abhorrent and awful is because it's viewed from our social lens that we have of
Mhm.
social expectations and societal like expectations. You look at it from an animal kingdom lens, their
Yeah.
behavior is not that
Mhm.
unusual. Like that is what a normal predatory animal will do.
Exactly.
And we are animals, we are higher functioning animals, we have a lot more cognitive potential, but that doesn't necessarily mean that we are going to
Mhm.
use that cognitive potential or that
What was never brought out of us.
or that our animalistic instincts are not still there.
Mhm.
um
Oh, they're there. That's for sure.
and so given that context, you can almost it almost allows for a little bit more. I would borderline say empathy, because empathy and understanding for me often take a similar feeling
Mhm.
shape,
Yeah.
but
Mhm.
for some people it might feel differently.
Yeah.
But I'd say a little more understanding for those people, um and the kind of hard in their unfortunate place within the world. Um,
Mhm.
but let's take a quick break, and then when we get back, we'll cover my topic, because
Activation functions.
we kind of went what'd you say?
Yeah, activation
Yes,
functions.
activation functions,
Mhm.
but kind of had a fun, interesting digression there,
Exactly.
which is the whole purpose of this thing. We don't want to stick
Exactly.
necessarily to rigid.
Yeah, we don't wanna be too rigid, that's for sure.
Yeah. Um, but when we come back, we will discuss our activation functions in machine learning and the role they play in making modern deep learning architectures even possible.
Ooh.
All that and more. So stay tuned. And we are finally back. I accidentally sent this back and forth a couple times. We are going to do a real quick test here and
Quick
make
test?
sure that Jacob's mic is sounding the way that it's supposed to, because we did a little bit of adjustment because we noticed that it was a little bit too
Yeah.
cockeyed.
So we're gonna test this real quick. All right, testing 1, 2, 3.
And testing with a reference for me. 1, 2, 3.
1, 2, 3.
Sounds really good.
Hell yeah, baby.
All right.
Hell yeah.
Perfect. Okie dokie, guys.
All right, joking.
Well, we are going to delve into activation functions, which are not maybe the most complex or even necessarily the most interesting, deep learning functionality that we could discuss, but they are essential, which makes them kind of interesting in their own way, because they set the stage for a lot of the other stuff that we do.
Interesting.
And is really sort of a fundamental concept in artificial intelligence. And this particular functionality was one that we developed based off of what we understood from watching human brain synapses fire,
Mm.
and was kind of an extension of that understanding in neuroscience,
Mm.
which is kind of a really cool, one of those really cool intersections um, that's developed between. Oh my God, my reflexes are amazing.
Dude. Okay, Spider-Man. That's pretty good.
Going to try and adjust this here so I can
Whoops.
make sure that I have a clear view of my notes that I wrote on it. But so let's think of when we're talking about neurons in the instance, in the context of artificial neural networks.
Okay.
Well, the way that we define neurons is a little bit wonky and different than they are defined in neuroscience, which makes it a little bit sometimes confusing coming from one.
Mhm.
I remember I was confused by it for a bit because I understood going into machine learning a little bit about how biological neurons worked, and was expecting them to mean the same thing. However, a neuron in a neural network does not represent a neuron in the same way that a biological one would. It represents a connection. So it essentially represents the synapse
Hmm.
itself. In fact, there
There's no cell body.
really isn't any sort of, neuron,
Mhm.
so to speak,
Yeah.
in traditional machine learning. It is like a synapse of connections between other imaginary neurons.
Mhm.
And so when we were talking about neurons, we're referring to kind of that synapse functionality. And to be fair, like that synapse functionality is where a lot of the action
Mhm.
happens.
So it's like those connections between neurons are practically like the gap junction of the
Mm.
connection between the synapse and dendrite, pretty much.
Yeah, it's like defining the characteristics of that synapse
Mhm. Okay.
at any given time. And so, um, inside, that artificial neuron, um, kind of similar to the way that dendrites receive signal from other biological neurons, axons, connections to the synapse, uh,
Mhm.
and those that like that. The signal travels along the axon, and then depending on the type of neuron that it is, and the synapse that we've got going on, chemical synapse, it causes cause a stimulation release of chemicals, which change the electrical structures of the.
Mhm.
All that to say that like those signals cause some sort of cumulative effect within the synapse, which then a can cause a change or firing downstream. You know,
Mhm.
in the downstream neurons. Now, artificial neurons are similar to that. Usually, the signals get summed up um, at a synapse. So you'll
Mhm.
have. We imagine this is our connection point, right, between two neurons. Um, so um, we have, or well, let's imagine like a group of neurons, 1, 2, 3, 4, like this, right? Each one, you've got like your typical lines drawing between all of them, right?
Mhm.
Um, that is called a dense neural net or a uh, um, fully connected neural net.
Mm.
Um, and it just means that every neuron is connected to every other neuron in
Yeah.
the next layer. So this neuron or this connection point feeds out to all these other
The
connection
other 4.
points.
Okay.
And so um, at each of those connection points, it sums up all the other lines that are going to it. So up here from all this, we've got six neurons, right? So that means 6 connection points are coming to this neuron up
Mhm.
here. It's 1. Those are added up.
Okay.
And so once those signals are added up, it is then typically, again, this is very kind of generally explained, but typically multiplied by the neuron's weight, right?
Mhm.
And so that some signal gets multiplied by whatever the weight. And so we tune those weights properly so
Mm.
that the signal going through it gets adjusted correctly
I see. Okay.
to achieve the desired outcome, whatever that is. And so just
Yeah.
an overview of kind of like how that part of it works.
Mhm. I'm guessing this is like the
Right.
precursor to
Yes.
how activation functions are
Um,
utilized.
Now, as you can kind of imagine, this would only really get you so far. It would only allow for a really linear transfer of information, um, because there is everything always gets transformed and passed on to the next portion of the network, and
Mhm.
um, that's kind of where the activation function comes in.
Mm.
Is
Okay.
at this kind of junction point. So before the neuron passes the signal onward, um, that summed signal, um, that combined input passes through what's called the activation function.
Okay.
The function's job is essentially to decide, should this neuron actually fire?
Hmm.
Should it pass on this information or not?
How does it determine that?
This introduces a key concept in machine learning that allows for our deep learning architecture, which is
Mm.
called non-linearity.
Nonlinearity. Okay.
It means things don't have to be linear. It's not just if signal fires, passes on to this neuron, passes on to this neuron, passes on to adds non-linearity, meaning that we can choose not to fire.
Mm.
We don't
Okay.
have to fire this, all of our
Mhm.
neurons. And this may seem kind of trivial and like why is it so important, to this process? But if we imagine a scenario in which neurons just pass their inputs along directly without any sort of, transformation happening. If you just you pass the sum of the signals along, no matter how many layers that you ended up stacking up in the whole network, you would essentially behave like one big simple linear equation. You can
Mhm.
send multiple things through like the neurons, but essentially it's all going to be one big giant equation that is going to play out the
Yeah.
exact same, the
Mhm.
exact same way in the sense that it has to use all of the function no matter what signal's
Okay.
going through it, right? Um, so it would only be able to learn very basic, kind of straightforward relationships between data points.
Mhm.
But obviously, the real world data is pretty complex, and there's a lot of intricacies and connections, uh, secondary and tertiary connections between variables and whatnot. So it's not that simple. Um,
Mm.
when even it comes to tasks like nuances of language and context and like understanding an object in an image, and things like that, it needs very non-linear um, equations to be able to account for all of this in any given situation.
Mhm.
And um, so think of it kind of like you need to be able to work within certain contexts. Um,
Mhm.
and so basically, by determining whether or not something fires or not, and in a way, also how it fires, as we'll kind of see in a little bit, we are able to add another dimension of learning
Mhm.
to a network
Yeah.
where it can now tune itself for contexts.
Yeah.
And
Seems like it takes it from a straight path, kinda like more one-dimensional to two-dimensional spaces that it
yes,
can
and
interact with.
exactly. It's like, okay, so let's not just tell you the map to directions, the shortest path from here to point A to
Mhm.
point B, um, for any specific context. Let's look at first off the other routes available, also the time of day, that it
Mhm.
is. Factor that into the equation, and then how long on average it takes you to get there. Like,
Yeah.
it's that kind of
Mhm.
a non-linearity to the
Yeah.
equation that counts for other variables, right?
Mhm.
Um, so to kind of help reinforce this idea and make sure that we have a clear understanding of it before moving on, um, I'll use an analogy, kind of just overall, um, inspired by biological neurons, which I kind of already touched on, but I want to kind of like refresh on how that works for people that aren't already aware of that functionality. Um,
Mhm.
so when a neuron receives an electrochemical signal or an electrical signal for that matter, um, from a dendrite at its synapse, you have the dendrite, you have your synapse, you have your axon, which connects to another neuron, right? Um, so when a signal is received there, the neurons don't always pass that along.
Mhm.
There's a specific threshold that has to be attained a lot of times for that signal to even be passed along the network. That is how you control whether portions of the network fire or not,
Mhm.
and if they're going to be useful to the outcome.
Yeah.
And we don't want all of our brain's networks firing at once. Imagine how exhausting that would be.
Pretty exhausting.
Like every time an audio, a frequency goes in your ear and vibrates your eardrum, like just all of the brain, like, at once.
You'd probably explode.
Um,
You'd eat a lot of carbs. Mm.
so our brains have that fire or don't fire threshold mechanism that determines when that action potential happens, and as a
Ah.
result, what downstream networks can get activated.
So, would you wanna think of it like, this is how I'm kinda thinking about it. Instead of maybe, like, the electrical threshold, it's this relevance threshold, where once it reaches that point, it starts to then continue down that path.
That is a great way of putting it.
Okay.
And in fact, I think I might have used a similar term when I was putting together my notes for this later on,
Mm, nice.
um, when describing some of the stuff. But yeah, that's a really,
Okay.
really great way of putting it. It's kind of like a relevance factor.
Mhm. Nice. Okay.
And more even, or like in addition to relevance, also, um, in addition to like how relevance, how much relevance, also maybe sometimes in what way,
Mhm. Yeah.
and I'll maybe explain that a little bit more in a second. But and for those that are having difficulty grasping this, you know, to this point, imagine it like a gate. Like the easiest way to imagine this kind of thing is like a gate that will only open if they have seen you around town enough. Like, like you have a specific, maybe,
So you're regular
yeah, you have like passcodes or something like that, that like, that, or people that in, it's like trying to drive through one of those private neighborhood gates, and
Yeah.
like you have to tell like people
Mhm.
who you're there to see.
Where what's the
And
address?
if it's somebody that, they feel like, is, if feels like it's important for you to get in, they'll open up
Mhm.
the gate and let you in. That's
Yeah.
kind of how, it's a very rough analogy, but it's kind of how those threshold, signals
Yeah.
work.
Or they'll put your name and information against the system they have, and then if it clicks on,
Mhm.
good, it's correct, then it lets you
Exactly.
in.
Exactly. Yeah. And like, or like a passcode, you're putting your
Mhm.
passcode, the right number into there. And if it's a valid one, fires and
Okay.
opens up the gate for you.
Mhm.
And so we, when we combine the signal at the neuron, that's kind of like the summing of the trying to come up with that passcode.
Mm.
When we add up that signal there in the synapse, or in our case, in artificial neural networks, neurons, but the we're coming up with a "Can I please pass?"
And
code.
that's determined by the initial training of the network?
Um, I'll get to
Okay.
like kind of what decides that when I talk about the different types, because there's a lot
Okay,
of
yeah,
different types of activation functions.
makes sense.
Um, so let's talk about, actually, let's just go ahead and dive right into that, because
Oh,
that's really
great.
what we need to discuss next. Um, the, Now that we kind of understand a little bit about why they're necessary or why we need
Mhm.
them, the how they work will give us a little bit more of a clear understanding of what's going on underneath that even, kind of controls that.
Mhm.
Um, and this is kind of where we get into the specifics, and we'll go over a little bit of math, but it's not really complex math, so it's fairly easy to grasp. The first one, and this is probably the one that we see the most often, is also probably the one of the oldest activation functions out there. It's was used as early as the development of logistic regression, I believe, and is just a really solid, activation function. But it is called the sigmoid function.
Yep.
And is also known as the logistic function in some cases. Most machine learning engineers refer to it as sigmoid function. But basically, what sigmoid function does is that it converts any number, squashes it in between 1 and 0 with a maximum capability of 1.
Okay.
So you'll notice if you actually take a look at the formula here for the sigmoid function. Yes, that is the case. Okay. If you actually take a look at the formula and you try out different numbers as inputs, once you get above a certain point, you hit 1 at a certain point. No matter what number after that you input, if it's beyond that number, it's always going to be 1, a maximum of 1. And so if a neuron's sending a signal that's way greater than that maximum, doesn't matter. It's still going to be 1.
Okay.
And so with that kind of comes some limitations and some problems that can arise if it's used in the wrong context, which I'll discuss in a second. But basically, real fast to refer to math here, it's basically f of x equals 1 over 1 plus the basically say x raised to the Euler's number, which 2 point something or other. I don't remember what that is, but it's basically Euler's number raised to the power of negative x.
Okay.
But it basically creates an S curve. So we can imagine with the top, meaning that as it fizzles out over the top, that means that the larger numbers are gradually going to kind of get squished more and more into that top range, whereas the middle numbers are going to be a little bit more spread out in range.
Okay. I see.
And so it basically takes any number you want and like number range you want and like just like squishes it down into that S shaped curve. And like if you were to give it a really high number, still going to get planted at that top portion. In fact, like I'd encourage anybody to look up a sigmoid function and actually math out on your calculator, because you can do it.
Oh yeah.
And try like different input numbers for x, and watch what happens to the number, because it starts making sense when you do that. But basically, what it is just a number that helps contain things. And this is, particularly useful because it provides not only a smooth kind of gradient for learning, but the output being bound between 0 and 1 makes it useful for a whole host of applications, such as wanting to like a binary classification, not just binary classification of 0 or 1, but 0 to 1. So like how much of this binary classification does this exhibit, this input exhibit? And, you might get 0.8 or something like that, which lets you know it's pretty high resemblance to the data we're trained on. So it's probably, would fall within that classification range,
I see.
which gives you kind of a normalized universal
Mhm.
number to work with
Yeah.
there.
And it really seems like when used in its correct context, there doesn't seem to be any sort of number that you could use or value that you could use that would not be able to exist within that 0 to 1
Mm-hmm.
range, Like, it's very
Now, that actually kind of leads into one of the cons of using this in the wrong context,
Mm.
which is that it suffers from something called a vanishing gradient
Okay.
problem,
Mm.
which is basically describes the phenomenon that for very large and very low numbers, i.e., numbers that are going to reside at the top or bottom of the S, the actual um, numeric representation of that squashed value becomes basically indistinguishable from 1 or 0.
Oh.
And so if you were to have a really, really, really high value, it's all gonna look like versus say, okay, let's say we put an input of 100 in there, and we put another input of 1,000 at that neuron. Those are both gonna look like the same thing because of how that S curve, that it becomes flatter and
Mm.
flatter, like the closer to the top that it gets. And so the less change happens in their representation of that number.
Mhm.
So we have 100 is at the top. You have 1,000 is further down the line, but at the top. And because it's almost flat, there's almost going to be no difference between those two.
Yeah.
So you don't capture that representation for large numbers or low numbers, which leads to a vanishing gradient problem.
Mm.
And
I see.
So this can lead to a whole host of other problems downstream. This can cause the learning to slow down or even stop.
Mm.
It can also cause um, can sometimes cause biases that were unintended, and because it's not capturing the data properly.
Mm.
Um,
So it's like it's capturing 1 point, but then it kind of, like, doubles that weight in a way that it shouldn't have.
yes,
Yeah?
yeah, it's kind of like it's capturing a portion of the data in its relation to itself
Mhm.
really accurately, but there's a large portion of that data that exists at the extreme ends
Yeah.
that is not capturing
Not capturing.
properly.
Okay. Yeah.
Um, and so as a result of that, you see it in specialized cases. There are times like I think it's actually one of the functions used within the LSTM cells that make up the LSTM. I think it's
Mm.
one of the activation functions. I think it's the sigmoid is one, and then uh, the con activation function
Mm.
is one of the others. But
You'll have
anyway,
to go over artificial cells at some point.
yeah.
I think
Well,
that'd be
you're
interesting.
talking about the LSTM cells.
Mhm.
Yeah. Those are like basically kind of the building block components that make up an LSTM. So it's
Ooh.
similar to an LSTM because it provides its functionality.
Yeah. Nice.
Um,
So how do
the
we, help with this vanishing gradient?
yes, the we came up with several other activation functions to help with that. So we have one of the other ones that we have and we use a lot. One of the common ones is the TON activation function. Um, um, and specifically, the I believe it stands for tangent hyper tangent hyperbolic function.
Mm.
I think is what that stands for. The tangent hyperbolic function. I'm 98% sure that's what that is. Um, but if memory serves, the tangent hyperbolic function is basically similar in shape
Mhm.
to the sigmoid function as an S curve, but instead of squashing things between 0 and 1, it squashes them into a range of 1 and negative
Oh,
1,
yeah. Yep.
centering the data around 0. And the algorithm specifically is f of x equals the exponent of s or of x minus the exponent of negative x over the exponent of x plus the exponent of negative x.
Okay.
Which doesn't make much sense, I know, mathematically in most people's people's head right off the bat. But all you need to know pretty much is that it's designed to basically split it the range in half and squish it between like 0 and negative.
Okay.
Or I mean, sorry, 1 and negative 1. And produces that same, S-shaped curve, but centered around the 0 instead. And the major advantage of that is that that having outputs that are centered around 0 often majorly helps the learning convergence process. So basically converging to that optimal kind of state in which, you've learned everything that your architecture is going to allow you to learn in any sort of meaningful way. You could continue training and potentially increase it a tiny bit, but not where like that's kind of what that refers to. And so the that tone function is often preferred over the sigmoid for hidden layers in a network, which just means layers between the input and output. But especially before the next activation that we're going to talk about function became dominant, which was called the ReLU.
ReLU. Oh yeah, you
function.
talked about that before.
But this one was really popular and still remains popular due to its kind of zero-centered property.
Yeah.
The fact that it also allows you to capture negatives. It's not just 0 and 1, but allows you to capture, kind of a negative. What is the word I'm looking for? Allows you to separate the data between positive and negative elements. Create some kind of create its own mapping there. But okay, so the next one that we're going to talk about, and this is just again a few of the ones that have been created, but next one is called the ReLU function, or the rectified linear unit activation function. And this one, as simple as it is, and it's hysterically simple, but was a game changer when it happened. And it's just, to me, is so funny that it had such a big impact on our ability to do things, considering how obvious it is. But the algorithm is basically f of x is max 0 or x. So whatever's the maximum there, 0 or x. Like, so if 0, okay, so let's explain that a little bit more. It basically means yes or no. Do I let this through? Do I not? If it's below 0, I don't. If it's above 0, I do.
Okay.
That's all it means. And
Interesting.
it's so simple.
Yeah.
And yet it made such a big impact on our ability to train different types of neural networks.
Out of the 3 you mentioned, is the ReLU the most recent that was developed? Okay.
Yeah.
So what did it change? Like, how did it make it, like, I can kind of get a good intuition as to why, but I guess I would like an further explanation as to why, like, it really dramatically was a game changer. The sigmoid function seems like it's pretty good. How does this ReLU that has such simple components really, make a huge dramatic impact?
That's a great question. The reason is because it avoids the same problems that both the sigmoid and the ton can run into, which is the issue. There are issues with really high numbers. They can't handle those because the movie, you can't handle the truth. Like they can't handle those large cases because of that squashing function that happens there.
Yeah.
And it causes vanishing gradients and a whole host of other problems, which means that data now has to be fed and handled and by the network differently, and can be really problematic on a lot of different levels. The ReLU function doesn't take care of what scale a data is in
Mhm.
when it goes through it.
Yeah.
It is a question of, is it above zero? Is it below? That's it. And that's all it cares about, and it passes it on. If it is, if it's above zero, it passes it on. And that allows for a gating mechanism that the network can then adapt its weights to utilize. So it'll
Mm.
adapt those weights for those synapses to utilize that gate properly, and
Yeah.
maybe bring things that shouldn't be passed on to a negative number through the previous weights, so that when they hit that gate in a specific context, they're not high enough to open it.
I see.
And
Yeah.
so that allows for non for us to change to have a sort of gating mechanism built in there, and a activation function. It doesn't change or care about the scale of our data,
Mm.
which is, you know, a huge advantage. Now, there is a problem that arose with the ReLU function, um, despite it being, computationally really, really efficient because it's just
Yeah.
calculating zero, above zero or
Mhm.
below. Um, it has the advantages of being um, of avoiding that kind of vanishing gradient, and not really caring about the scale of the data. But it can also suffer from a problem called the dying ReLU, or the dying neuron problem, where if a neuron happens to become consistently negative,
Oh, yeah.
um, during training, then that would be due to large gradient updates, like to have learning rate. But it would always, or the ReLU function would always output zero.
Mm.
So if there was enough of a reason for a neuron to consistently output negative numbers, that would lead to a gate that never opened, which would lead to a pathway that never activated, and thus no more updates, which is why it's called the dying neuron problem.
That's that's kinda cool because it really does seem like the, what happens when new neurons get developed in the brain and attempt to integrate. If they're if they
Mm-hmm.
never form any, positive electrical charges and
Mm-hmm.
strengthen those connections, they will pretty quickly die off,
Oh yeah.
There's always that gate that
Yeah.
stops them from maintaining those
And
connections.
without that kind of flexibility there, and it's the same thing like with the sigmoid function, it's not centered around zero. Means that if it gets negative, like those negative
Mhm.
weights, like it can also lead to,
Yeah.
problems because of that. Similar thing like here, if we imagine the um the ReLU function as um as a line. Once it hits zero, no matter where the data sits on that line, once it hits zero, it flattens out. It's going to get the
Mm.
same response no matter what.
Yeah.
And so, as a result, it can't handle consistent negative values very well.
Mm.
So that can lead to problems if that's something that your network is going to have to be dealing with.
Yeah.
And so that's why the next one, like improvement on activation functions, and specifically the ReLU function, was developed. And basically, it was it's called the leaky ReLU function,
Leaky.
the leaky rectified linear
Mm.
activation function. Quite a mouthful, but the leaky ReLU is the one that I always revert to if I'm needing a ReLU function, because it avoids that specific problem of dying neurons.
Mm.
And it does that by basically introducing a small negative allowance. So instead of cutting off at 0, it instead allows for a slight decline below the 0 line, so that even with negative information, there's still going to be information
Yeah.
that can reach the other the neurons.
Mhm.
And so uh, basically, it allows for a small fraction of that input to be output to avoid a neuron actually dying out.
Yeah.
And the specific algorithm for it is f of x equals the maximum of alpha times x or x,
Mm.
where alpha is a very, very small number close to 0, but not 0.
Yeah.
So we take our input, no matter what it is, we multiply times 0.00001 or 0, input times 0.001,
Mhm.
and that will give us a relevant, but not really very statistically significant number that we can output to avoid complete loss of information.
Yeah.
Um, and so that doesn't always fix things. It's not going to 100% of the time be better than Relu, but it does add
Mhm.
that improvement on it, and is kind of almost a better general go-to if you're not sure.
Yeah.
Um,
Like, if you can place the others in its specific context, you wanna utilize those,
mhm.
that leaky ReLU activation function is the best place to start,
Right.
I'd say.
Yes.
Okay.
If you're just like
Mhm.
spitballing with something and you're kind of pitching ideas during research
Yeah.
and you're not really sure which one of
Mhm.
those you want to go with, sometimes the leaky relu can be a good one. Or you can try the relu and just see if you run into a problem
Mhm.
with it, and then if you do, use the but I'd always err on the side of like it makes sense to allow for
Well
so the go ahead.
well, I thought of an idea. I just wondered if anyone's attempted to do this, where you have a ReLU activation function that's just not the leaky one, it's the normal, 0 or X, and you have that, but as it reaches a point of getting zeros consistently, it automatically lowers it to a slight negative value.
That's a very interesting question because it actually kind of leads to one of the other developments in the ReLU activation function, which was called the PreLU activation function,
Mm,
um, which uh, which basically um, is a version of leaky ReLU where it learns that secondary parameter.
hmm,
So that value of um, that small multiplier value that we were multiplying
yeah,
by 0.001.
mhm,
Instead of setting that be a static value, it would learn what the best place for that was.
mm,
So it's like dials that knob
yeah,
during training to figure out where the majority of the data was residing and how best to avoid dying neurons while also um, kind of not skewing the data.
yeah,
Um,
that's
so it's a definitely a big improvement in many cases on
mhm,
both of those. Like
okay,
it kind of adds that trainable parameter there that figures that out for you so that um that we don't have to rerun models with different parameters to determine that impact, it will automatically figure it out because it's in the best position to do that because it's within the training
Yeah,
process.
that makes sense. That's cool.
And then the last one that we're going to go over real fast for activation functions is the soft max activation function, which is probably one of the most useful and most common activation functions.
Nice.
It's typically only used though in the final output layer
Okay.
of a network, specifically for multi-class classification networks. Situations basically where you want the network to assign a probability of each category.
Mm.
So like this is how much I think it fits within this category. This is how much I think it fits within this category. This is how much this category. So if we were, for instance, if we were training a network on classifying, let's use a more interesting example of classifying somebody's emotions on their face, right? What would be really useful because of the complexity of human expression is to be able to classify not just the primary emotion that we detected on their face, but the and and so basically um kind of squishing them so that everything fits between 0 and 1. The model might output we'll just use whole numbers for the sake of easy understanding in this case. But say the model output a likelihood or an amount of 3 for depression and an amount of 100 for interest and amount of 40 for satisfaction. Like it would take all those values, squish down their ratios in between 0 and 1
Oh, nice.
so that they all added up equal 1.
I see.
And that gives us a amount that we can now universally categorize things as in a scale that we can work within. No matter what the output of the model, we can universally work within the scale between 0 and 1.
That's cool.
Yeah.
Nice.
So that's
Very important.
activation functions. They serve a variety of purposes, some of which for transforming data as it goes through the network, but a lot of which is to control the relevance of data to any specific run. And there are also kind of brings up interestingly one of the downsides of modern deep learning architectures is that it's not optimized for situations that don't require full network utilization. We have elements that help with things like that, like the fact that we have the ReLU activation functions allows us to essentially kind of turn off certain portions of the network or turn on certain portions of the network for different scenarios, which allows us to tune a network for a wide variety of tasks. But nonetheless, the network is still loaded and is required to be in the shape that it's in order to be able to run, which means that everything has to be there. And so there's a lot of things that just are not kind of as optimized as they are in the brain's, kind of networks and but they do those things like that do take steps towards helping improve that and replicate a lot of that functionality.
I think, it would be pretty revolutionary if we were able to completely replicate the brain's error minimization process. That would, I think, would be one of the biggest breakthroughs we could make in combining like the best parts of our neural architecture and artificial architecture as well.
imagine, if you will, in order to kind of just like help people better understand kind of um, the ton activation functions and uh, um, some of those others, the sigmoids that might be a little more feel like a little bit more abstract.
Mhm.
Imagine that you are in front of a castle. You want in, right? Because
Mhm.
it is about to get really hairy out there, and you're like sprinting. You're like, there's a horde of barbarians and crazy dragon riders or whatever like behind me. Like, get me out of here. I
Yeah.
want in the castle. And but in front of you, there's a moat. Beyond that moat, there is also a wall. Um, the what the those activation functions kind of can do sometimes is they provide those blockage or allowance mechanisms. So like maybe okay, you have a bunch of people that there's 1,000 people with you, like you're all running. Like by yourself, you're just gonna probably get squashed like pretty low,
Yeah.
like in the moat,
Mhm.
and probably no relevance. A lot of people, you have like 1,000 people, you could stack them on top of each other and you could step on them and then stack them up the wall and step up the wall, like onto the wall.
Yeah.
You get enough people and it's not going to matter like how many people don't get through because
Some
of how
people
many
get there.
people are getting over the wall and
Mhm.
flooding into the town, eating all the food and stuff. And like that's kind of like what a
Mm,
similar
okay.
similar kind of thing happens with that S curve.
That's actually a really good analogy.
Yeah.
Yeah. Okay, I see. I see. Mm.
So it does have that transformation effect that we were talking about earlier too. But there's kind of an element of really low numbers aren't going to matter. Really high numbers, you know, matter less. But you get that optimal
Mhm.
range, like of okay, we have 50 people providing support for other people to get into the town, like for another 100 people to get
Yeah,
in town. Like that's optimal.
that
Like
works great.
there's
But if you were to stack 100 people on top of each other, try to climb over, you just fall and die,
mm,
you know?
well, I mean, what if you? It's more of like if you were to if 50 people were to die so that one person could get into the town, that would be very relevant for that one person that got
Yeah.
into the town and relevant for those 50
Mhm.
people that died.
Yeah, I
They
mean, yeah,
all
it's pretty important.
died to save that one person get into the town.
Mhm.
But if you had 1,000 people that got into the town, right? It's going to be less and less relevant for each of those
Yeah.
people that got into the town. That sacrifice is going to be less and less personal, and
Mhm.
kind of a
Yeah.
direct connection there.
See.
So the those scales become kind of less and less
Mm. Yeah.
relevant the larger the amount
Mhm.
gets.
It's like how important is that one person that got over?
Mm,
And that lessens as more
right.
people
Or the
come over
one
that
person
wall.
or the person that didn't get over. If there was just one person there and they'd like gotten the moat and couldn't get over,
Yeah.
couldn't get up because they didn't have enough people,
Mhm.
like but if there was like a ton of people that died like in the moat and on the wall. This is like I'm like going crazy with this analogy right now. This is not a great analogy to run with, but like, it's just an interesting one that my tired brain
Mhm.
was coming up with.
Yeah. I mean, that's interesting, I mean, often we think, kinda like the king of the hill, kinda like those piles of bodies, the one
Mm,
warrior at the top, kind of one,
yes.
the most relevant, who was able to stand at the top. And so I don't know, just kinda going with that, stacking bodies on
Think
each
of it
other.
like you can almost think of it like this. What if normal, what we view as normal, was not normal?
'Kay.
Instead, what if normal levels of intelligence was rare and it was more common for people to be really, really smart or really, really dumb.
Hmm. So there's more disparity.
Right. And so the more data gets lost in those extreme ends. And
Mm.
but if you add a distribution, like more of a distribution along like this middle axis there, um, then it becomes easier to create a scale.
Yeah.
And kind of in a similar way, if you have a lot of extreme values in a sigmoid function and minimal values distributed amongst, you know, the mean, then a lot of information is going to be lost there.
Yeah.
Whereas if you have a lot of distribution amongst the mean and
Hmm.
little extreme variance, very little information will
Hmm.
be lost.
Yeah. And if you have that, I don't know if this is exactly relevant, but if you have lots or high levels of distribution where everyone kind of has this place in this kind of uh, this distribution where you always have one person who's a little bit smarter than you, much smarter than you, and a little bit less smarter than you, and you have these extremes that kind of give
The
representations of the
bounds.
bounds, and then those bounds get understood on different levels because you have someone who's slightly less intelligent, who maybe didn't discover those bounds, but
Mm.
is able to comprehend them and is able to
Hmm.
transfer that information to um, lesser complicated interpretations, and then that all kind of meets in the middle where we have kind of like um, a way for everyone to weigh how important their where they are.
Yeah. Yeah. It's like, at a certain point, kind of almost similar to, I guess, again, I hate IQ tests, but similar to IQ tests, like
Mhm.
above a certain point, that distinction becomes less and less
Yeah.
meaningful.
Mhm.
Like, it's like these people are both way off the charts smart and, you know, s- very skilled at what they do in different ways. And that kind of because of those extreme values there, that distinction between them and the ability to comprehend the differences
Mhm.
becomes less and less
Yeah.
important and meaningful and
Mhm.
represented there.
And I
And also, who's going to make the test for that? Like,
yeah, that is true. How
like, who's qualified to make a test for somebody that is way smarter than them?
Mhm. Yeah, that is actually very interesting, I mean, like, there's the simple answer where it's like, well, I understand what kind of abilities that someone with my intelligence has, and so you kind of have, like, this you kind of gather, like, the 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 average of complex problems that people can solve, and then you say, "Okay, this is kind of like the medium," and then you kinda add more, um, complex uh, problems and you kind of just start to have a gradient of like, smaller and lesser people who can kind of solve those problems to get to someone who can, even
But what if you come across the person that finds the problem with your problem, like somebody that considers scenarios you haven't considered because you just
yeah.
weren't aware enough to be able to think of them, and so
And that's
and
why
and that was a lot of the just as a kind of exemplifier of the significance of that. That was a lot of the problems that I ran into in school with doing tests and whatnot, that I would get stuck on problems because they would be phrased in ways that I could see there being more than one option
yeah.
and right answer to,
Mhm.
and I could see ways in which other answers could be true because not all the information that was needed was given.
Yeah.
And so there, is an element of you can't account for what you don't know you need to
Yeah.
account for, which is
Mhm.
obvious. But like, if somebody is more intelligent in certain areas than you and is like more perceptive or whatever, like they has bigger knowledge base to work from, they
Mhm.
might see things that you
Yeah.
don't.
Mhm.
Um, and as a result, it might not be them that is um, technically flawed, but your system that is determining if they're flawed.
I mean, it's an interesting way of doing things because what they want you to do is identify patterns from past knowledge that you were
I
supposed to
like that
learn.
word identify.
You know? Is that what I said?
Yeah, I like
Oops,
that though.
identified. Well, I meant to say, they want you to
Identify.
identify certain patterns of past knowledge that you're supposed to memorize. And that is what they really want you to learn because that's what's going to be most useful in an 8-hour workforce, you know, an
Well,
8-hour
in
day.
typical
You know,
child test scenarios, yes, like that is the case.
Mhm,
With IQ tests and things like that, they're a little bit different in that they try and come up with something that is so basic to the type of skill required that it no longer bears personal
mhm,
relevance to anyone
yeah,
and is which is why they're doing it. They're trying to find something that they can just ask anybody to do. But that's also a problem in that, like,
yeah,
without relevance or any connection to the person's knowledge base, really,
mhm,
you're missing an entire portion of
for sure. I
intelligence.
mean, there's that's why it's IQ is still a pretty heated debate, you know? I used to
Mhm.
listen to Jordan Peterson a lot, and at the beginning, he would always say that IQ and intelligence is determined at birth. But over time, as I heard him talk about it more, he's kind of gotten to the point where he's now like, "Well, it's a very complicated process, and we're not quite sure if it's exactly, completely determined by genetics because there are so many there's thousands of genes that are all having a small little part to play
Does he
in
even
overall
understand how
intelligence."
the brain works? Like,
I would say so. I mean, he's a psychologist. I mean, it was just
like
he's
that's not how brain, like, neuroanatomy, like, works. And like, yes, I mean, as we get older and older, like, our brain's ability to change, like, diminishes.
Mhm,
But like, we are it's not only about our processing capabilities, which we can adapt over time, and our logical processing, which I even know from my own
mhm,
personal experience. I used to not have
yeah,
a lot of the logical processing capabilities that I developed later in life. Um, but it's not only that, but the knowledge base that you're pulling from and your ability to utilize that and to draw
mhm,
connections between things and
yeah,
um and the I think personally, and this may sound arrogant in and of itself, but I think it's a mark of incredible arrogance to um and stupidity to try and put somebody put somebody's intelligence down written from birth
mhm,
because of their
yeah,
genes. Like, sure, I'm sure that's a factor in the initial network, the initial stage that you're and hand you're dealt, and what you've got to work with.
mhm,
But that the amount of optimization and change that happens, like, can happen within the brain, going to determine
mhm,
your ability to utilize that environment. You might have somebody
yeah,
that has a great genetic setup, but doesn't optimize it at all and is
sure,
just completely, like,
mm,
wasting that. And you might have another person that had a really crappy genetic setup, but they did so much work on optimizing
yeah,
and creating, a better environment,
mhm,
um, that or and really kind of capitalizing on the areas that he was strong in, or she was strong in, and
mhm,
thus ended up with a more usable and quote unquote intelligent network.
And I think that's most people would agree with that, and I definitely agree with that statement. And the majority of what we know about our neurophysiology is headed in that direction. It's just the older generation of clinicians and neuroanatomists, they had this idea that sure the brain was plastic to some degree, but that's kind of where there's kind of like a category area there where we say it's plastic. And what is plastic? It's very malleable, but then once it finds its state, it kind of
Mm-hmm.
fixes there, right? I like David Eagleman's, who's a neuroscientist. I like his interpretation of like live wiring, where it is, which kind of makes more sense, where it's this wiring process that is alive and changing and constant and lives as dynamically as we do because it is us.
It's because we happen to settle into scenarios that are static that
Mhm.
network becomes static.
Yeah,
And why change if there's nothing within the environment prompting that change?
exactly.
And so, and I'm sure with a lessened use becomes comes a certain lessened likelihood of
Mhm,
change and flexibility. Like for instance, with um with something that is made out of like a rubber or like, even certain plastics. If you're constantly using it and bending it and whatnot, it's going to remain,
mhm.
flexible.
Yeah,
But if you just leave it over time, eventually it starts like kind of hardening and solidifying and
exactly.
whatnot. And so I'm sure there's a portion of that that
Mhm.
can be
Yeah,
attributed to that
for sure.
time process and the less
Mhm.
optimal body state, kind of over time as cells,
Yeah,
degrade. But there's also a huge portion that has to do with how we are as humans and the fact that we tend to choose comfortable,
yeah.
static environments that we're
Mm,
used to.
exactly. Because what's optimal for us is, you know, survival and propagation. And if we're comfortable, then we feel like we're in a state of survival. And if
Mhm.
there's no reason for us to kind of continue this very high intensity needing to adapt to lots of different situations and environments, there's no actual stress or pressure that is put on us to optimize our workflow for better navigating new novel tasks.
Mhm.
That's why, when you see, I think I've already talked about this, kind of getting deja vu, where you notice, unless there's like actual neurological disorders, a normal functioning person that goes into different fields, like emerging fields, and like in physics, like physicists, high energy physics, cosmology. These people, you'll notice they're 80, sometimes 90 years old, and they're so quick witted. They have wonderful information processes and are able to talk well, speak well, be polite, still be able to have full control over themselves. And it's the fact that they're continuing to put themselves in new novel experiences. And so there's a purpose, like like an actual biological purpose for continuing to survive. And that's fundamental to even the longevity of our health, Like I I I I think that one of the things that scares me the most is that through kind of this distracting world that we live in, there's distractions everywhere. And it's really hard to optimize our workflow, very much so. And there might come a point to where there is an entire generation of people who were never even put under pressure and feel no need to continue this survival process that's been orienting us for billions of years, you know?
Yeah, and there's definitely there's a component. I feel like there are a couple different components there that play a part. One is the pressure and intensity of the operating environment and how kind of
Mhm,
abrasive it is, or not. But there's also the dynamic nature or dynamic versus static nature, i.e., static environments versus noisy environments.
mhm.
I think it turned itself on because of my hands. Um,
It's fine.
but It's a little bit of a weird statement.
Not wrong though.
We're talking about the cameras here. Um, but we have our my parents' previous generation versus the generation that came after me with the um, Generation X. Is that, I think that's what they're
Yeah.
called. Um, are very good examples of this because you have one that is far more used to static environments where you go to work, come home, do the same thing every single day.
Yeah.
You get used to this routine. You have a family. You
Mhm.
spend generally the same amount of time as a family, do the same stuff, yada yada yada. That's their environment. Then you have Gen X that is growing up in a far noisier environment
Yeah.
with a lot more going on,
Mm.
a lot more noise from social media, from technology, from information, from phones, from politics, from simple, access to information in other parts of the world, to um, the activity level of sometimes of their day to day lives or their social lives,
Mhm.
and their ability to connect with their friends and all this stuff that has added new noise into their life.
Yeah.
I feel like there are times that you can benefit from both of those components. Optimally, you'll be somewhere in the middle. You get too much on one side of that or the other, and you now introduce a new problem into your life, which is, the main problem with noise is you can't disseminate or make use of information because
Mhm.
there's too much other information around it.
Yeah. And it's
And
very anxiety inducing too.
you can't, like,
Yeah.
you know, it's difficult to make meaningful use of anything.
Mhm.
And um, the main problem with static is it doesn't allow you to adapt and make use of other
Yeah.
things.
Become way too fixed,
Hmm.
and you end up with lots of, uh, you know, kind of trauma from our generation of people who have had this super, complex social network at the tip of our fingers for so long that we have intrinsically changed, where we are far more open to experience than our than the previous generation before us. And I wouldn't say that's a bad thing, I would say that's a good thing, actually. It's just the majority it's just the it's weird because there's such quick technological advancement where we have this capitalist system that is trying to take advantage of this and and, kinda suck everything out of us,
Trying to
really
make
just
us
make sure that
static
we're really entertained,
when
have all this stuff.
the
Mhm,
when we or the point at which in society that we are is one that needs to be
mhm,
dynamic and that wants to be dynamic.
yeah, mhm. They're trying to focus that dynamicism on entertainment, and then we have this culture that has been predetermined by our predecessors that is static and not optimized
Because they
for
like being
our
static,
environment.
and they're the ones in
Exactly.
charge.
And so it's like we're kind of the caterpillar in the cocoon right now,
Yeah.
you know? It's we're not exactly a caterpillar, you know? They did the routine
Who
stuff.
knows if we're ever gonna get out of that cocoon,
It's hard to
but we're
tell.
sure as hell wiggling.
Mhm. And I think that, while there is enough reason to believe that there's probably gonna be some negative outcomes for the future, I do think that the end result will be positive and that we might actually even be able to get to a type 1 civilization. And then, maybe through s some very interesting factors that it's practically impossible to determine, we actually are be able to form a a global civilization.
I know. That's another thing that I feel like the previous my at least my previous generation, the baby boomers, they balked at and rejected, I think primarily because of religious reasons and the fact that, like, the Bible has, like, presents character that's supposed to be, like, signify end times, I think,
I
as one
mean,
of those kind of one world
Yeah,
pushers,
one more
but
organization,
like
yeah.
I I genuinely believe that has to happen. In fact, it not happening is a sign that humanity is not evolving and adapting appropriately,
Yeah.
and species that don't evolve and adapt die.
I mean, should there be a king of the world?
No.
No, obviously not, and I think that's what most people fear when they hear of, like, a one world government. They think that one.
They're like, "Oh, well, somebody corrupt is gonna be the
Yeah,
one in charge, like,
but when you
powering it."
have
It's like,
like, a very diverse representation.
it doesn't have to be that
Exactly.
way. It's because of our experience with
Mhm.
governments that we
Yeah.
say that. Like, come on, guys, we're smarter than that.
Mhm.
Like, they look at the problem areas that cause issues and where people tend to, um, you know, try and finagle their way into,
Mhm.
and look at the potential areas that could oppose
Yeah.
change,
Mhm.
because that's ultimately what somebody in power would want to do, is oppose change.
Yeah.
Because anything that causes change in the system can risk their position in it.
Mhm.
And so,
But systems that don't change over time
exactly.
crumble, you know?
So basically, look at the places that could resist change,
Mhm.
modify it,
Yeah.
and make sure that the decisions that are being made are ones that are being made by people that are in a intellectual position to make those decisions
Yeah.
and are in a position of relevance
Mhm.
to those decisions,
Yeah, I
because they
mean,
have an investment in making sure that the best one is made.
it was probably one of the worst decisions to make to put people who really have no business making decisions,
President
making
and a
decisions.
Congress and a House and like making decisions for everybody.
And then
Like,
on top of that, we have business people controlling who gets the funding.
yeah,
And so even then, it's not even optimized for better investigation into what's really out there in the world, and how to optimize things. It's purely profit and power currently. And
yeah.
I hate saying
Well,
that.
it's
Like,
like
I don't want it to be that way.
interchange. Like, it's like
Mhm,
profit brings power, brings profit, brings power.
mhm,
Like the two are um kind of used interchangeably, and often like the because of just like you're saying, the way that the system is set up, it gets into this feedback loop that it can't break itself out of.
yeah,
And
'cause those charts need to keep going up.
it's
Can't see a downwards momentum.
like,
What
why
would the
would
shareholders think?
it's nobody in power is going to want to, that actually has the ability to change a system, is going to want to change the system.
Exactly.
They don't have an investment because their security lies within their power and positioning.
Mhm.
So the people that would want to change the system and would make the best decisions
Yeah,
are the people that really like have no
yeah.
power whatsoever.
Mhm,
And that's like one of the major problems that needs to be fixed,
mhm.
because I feel like if you put that in place and you allow the system to be dynamic and to be ever changing and evolving, except for single pretty unmovable rules,
Yeah.
for instance, implementing those core functionalities
Mhm.
so that no one group that gets into decision making can screw things up.
Yeah, exactly.
You implement that core element there, and then let the system try things out and evolve as
Mhm.
it needs to.
Yeah.
And it will settle into ways that work
Mhm.
on its own.
Yeah. I mean, it's taking game theory to the next level on a not just a uh organic of fitness, but an actual like a society fitness
Hmm.
where we have it figure itself out through different optimization processes. And if there's not the fear of warring with other countries, without the fear of seeing or being weak.
Of decisions that you making being the end of you.
Mhm.
Yeah.
Exactly. There's what we need is grace.
Yes, we need the
And
ability to fail and to
Mhm.
recover from that failure
Yeah,
and to learn together how to not do
yeah,
that in the future, you
and
know?
that and one of the main things is, I think, in order to get to that point, we have to optimize resources, right?
Mm.
Because we
We
still
need people
have
to
Yeah,
feel safe. We
exactly.
need people to not feel reliant
Mhm.
and um, to there to be no real value to power or money.
Yeah. I mean, it just it goes back to um, that that environmental determining factor of what you view as relevant information. If we're still living in society where it's paycheck to paycheck, am I still gonna be able to afford my apartment next month? Am I am I going to land that job that'll finally give me some sort of comfort in life? You know, is my girlfriend gonna stay with me? Is she not? Are we gonna go to war with this other country? You know, what is Trump's tariffs gonna do for me? Am I gonna have to pay $12 for, for some eggs? That, these
How
problems
do I pay
are
property tax on this?
Mhm, it's like there's a reason why the majority of the population can't kind of supersede this kind of 100 IQ, not because it was predetermined at birth, because
They don't
the
have time.
information, the relevant information of their environment is curated for the task of survival that need complex properties, but only to a certain majority, and overcomplicating that will probably just hurt them more, you know?
Right,
But if we're able to have this optimization of technology where we have healthcare that is good, and crops that we're able to distribute out in a nice way, to optimize all of these fundamental needs, which, by the way, why would we have to earn those? Isn't the point to not need to earn those? Like, to
right,
have those as basic necessities. It seems like there's this weird kind of view that that's actually a bad thing, that, "Oh,
right,
that's socialism."
right.
That's not
Exact
socialism at all.
yes.
Not having to pay for food
That's
is
to
not
me is a sign of tremendous progress as far as our
Mhm.
like cognitive abilities as a society that we're
Yeah,
able to evolve to the point where we are so much further from our animal upbringings that we now have surpassed a point in which we can work together enough that everyone is provided for, not
exactly.
just ourself.
Mhm.
And the ability of choosing to see beyond
Yeah.
that
Mhm.
primal me first mentality as your
Mhm.
sole point of view.
Yeah, it's, one of the main arguments is like, "Well, we just don't want, parasites kind of just kinda living off of society doing nothing." And what I
People get bored, bro.
Yeah.
Have you ever tried? You probably wouldn't know because most people haven't been in a position where this has been
Mhm.
even an option for them.
Yeah, exactly.
But have you ever, been in a situation for a week where you have had absolutely nothing to do?
You're gonna find something to do.
Like, you are going to be bored out of your mind, and
Mhm.
you will find a way to find value.
Exactly.
And
How we're oriented.
COVID is a primary demonstration of that. Despite the lack of social elements that we a lot of people couldn't go out and be social,
Yeah.
get any sort of thing like that. People were finding things to do during
Mhm.
that time, and they were finding value in other things that they wouldn't necessarily
Yeah.
normally find value in.
Mhm.
And it's uncomfortable, yes, it's uncomfortable to have a value shift um, and to have to give up something that you
Mhm.
think is valuable to you. But once that uncomfortability process is over, you and you start settling it, you're like, how come I didn't do this so long ago? And as a society, if we were to integrate these components where people's needs were being provided for, what I believe would happen is there would be a fundamental shift in values. Yes, people don't need to work anymore for money to provide for themselves. But no, people need to work in order to find societal value.
Mhm.
Like
Yeah.
your value in the society is almost in the what you bring to the table, and now it's in your knowledge level and
Mhm.
your ability to kind of contribute back.
Yeah.
And so you choose to do these things because in some form or another, because not only there are the things that you're interested in and that you're good at, but they're things that um that show, your
Mhm.
value and care for society.
Exactly. I mean, it's all about, you could say it's even curating curiosity.
Right.
That's the point. It's optimizing that environment so that you don't have any of these deficiencies that lead to coping mechanisms that cause you to be a parasite in
Right.
society. That is
Exactly.
actually a defect, not something that is intrinsic to humans.
Mhm.
It's a problem that
Is people
humans.
getting
Yeah.
so worn down and tired of trying to find ways
Mhm.
of navigating an unwinnable scenario for
Yeah.
them that they, when given the chance to give up and to rest, so to speak, they take it.
Yeah.
That's a result
Mhm.
of exhaustion and a frustration with the environment that they're
Yeah.
in. People enjoying the environment they're in are excited, like, for
Mhm.
life. They're
Yeah.
excited to get after things. They want to, like, learn more and to be around the people or the stuff that they're
Mhm.
doing, and they will choose to, um, to find meaning and to find a pursuit
Yeah.
for things, and I know that because I've been there, like, myself before, in which I was in scenarios where, um, either both I've been on both up ends, times where I didn't have time to even think, and so I was so caught up in, like, the daily grind of, like, of making
Yeah.
money and paying bills and whatnot,
Mhm.
and then times where I did have ample time to myself to think, and I could have just sat back and done nothing,
Yeah.
but that's never, like, the outcome of that situation
Yeah.
for me. It is a, "Well, God, this is boring."
Mhm.
Like, I'm going to find value and
Yeah.
meaning by enhancing myself in some
Exactly.
way.
And there are there are critical periods in people's lives where that innate kind of dramatic emotional significance gets associated with the direction they want to go in life. And oftentimes, that critical period was not able to have any effect because it was looked over because of the stress and the noise that is constantly surrounding people. And the fact that, like, even for me, I've noticed that, I'm working a lot right now, which is totally fine, but I can feel myself going, man, if I didn't have that first initial emotional significance that associated my pursuit of knowledge. Right now, I would spend every waking moment that I could just relaxing, just
Mm,
having some sort of time to
true.
myself, you know? But instead, because I had
You
that
now have
critical
a
period,
direction to
yeah, where
go.
I didn't work for the time I was kind of just in college for a little bit, and even then it was like 3 classes, and they were online, so I had so much free time, right? And that allowed me
Exploration
huh,
period.
that exploration period. Nobody gets an exploration period anymore.
I know.
Like, I think.
They all, like, immediately get thrust into adult life in some form or another.
Mhm.
And I, like, that was, oh man, one of the huge things that I found value. Initially, I went to college for marketing is
Yeah.
what I went to, study in
Mm.
college. And then after, um, like, only a year or so in college, I was fed up with the college system as well as all the irrelevant information that I was learning, as well as the the subjects and the way that that they were being taught, and um, didn't I found realized I was doing it just to have a degree.
Mm.
I was not doing it because it was something that I was particularly interested in,
Yeah.
and so I had a period of time there where I was waiting tables and bartending and getting some work
Mhm.
experience, and that was great for me to have around that time rather than going to school and forcing myself into a specific role. and groove, have that exploration period of time where I tried new things, figured out what it was that I liked and what it was that I was interested in, and got the time and freedom to latch on to certain
Mhm.
things. And
Yeah.
it really felt like it made me a far more well-rounded and human being with a sense of purpose and
Yeah.
passion, and in a
Mhm.
way, um, to the point that like I know other things now enough to the point that I'm not going to get stuck in any
Yeah.
specific role.
Mhm.
You can't stick me into a role and have me just be like, okay, this is my life now. Going to this, doing this, and when I come
Yeah.
home, I don't know what else to do. Like it's never a question of I
Mhm.
don't know what else to do now. It's
Exactly.
always there are so many things else to do.
Mhm.
I don't know which one to pick, kind of
Yeah.
thing.
Mhm.
And so I I think that it's just people can't imagine other different ways of doing things
Yeah.
that is the cause of that kind of rejection.
It's so sad that there's a large majority of people who truly aren't living a positive life, and it's not their
It
fault,
isn't. Yeah.
Genuinely not. And I know that, like, a part of me is like, well, I know that they could s learn how to optimize their experience for, maximal success and positive experience in their life, but that is not something that comes in a high stress environment, especially one that is it was different when we were tribes in a community that were hunter gatherers and survived based on doing these very fundamental things like gathering food, hunting, farming.
You're right. There's a
There's
difference between a high stress rigid environment and a
Mhm,
high stress adaptive, like
exactly.
dynamic environment.
Theirs was adaptive, and ours are far more complex, and we have these ideals that are represented as to the American dream, or what the top 1% looks like in life, and these are our goals and what we're
I'm
striving
still not
towards.
quite sure I understand what even the American dream is.
100K a
Like, what
year,
is our dream?
nuclear family.
Make money and
Yeah,
drop bombs? Is that the thing we're going for?
yep, but only on our enemies. So, it's, these the ideas we look towards, first of all, are fundamentally hedonistic, except maybe like the one like the nuclear family. I would say having a family is something that is a genuinely good thing to want, and it's depending on who you marry is going to be something that is very positive. But the the goals we have are not optimized for positive experience. They're optimized for a capitalist society, making people money, and the the complex dynamics that we live in are something that I would say represents a want to showcase that you are at the peak of human civilization, that you are at the top, that you have the fancy cars,
Which
the hot
involves
woman.
having the most money.
And it's and money is such an interesting concept because it's so new. It allows us to do all these incredible things, open so many doors for better experiences, but there's actually really no intrinsic
Right. Well, it
value
was a really good
in it.
conduit for almost in the same way that like a translator can be useful for a
Mm,
time.
yeah.
Um, and it it served a purpose at a specific
Mhm.
point in societal development. But our problem was that we latched onto it and we designed our society around it.
Yeah.
And it's not
Mhm.
a good thing for that. Like it's not
Yeah.
one of those core pivotal things that just has so much intrinsic worth to
Yeah.
society that like it's worth building a society around. It's
Mhm.
not. It's
Yeah.
a tool for a specific point
Yeah.
and then nothing more. When a better tool comes along, it needs to be replaced.
Oh, for sure. I think that it should have been a loop around. I think, we started at a bartering system. We had gold-backed money that was, useful when it came to transactions and quick, money transfers, transfer of resources. And then we got to the point to where it just stopped being gold backed and it became kind of this like standard because people believe that it's valuable. It's valuable. And then now we're at a point to where it's simply a use case for manipulation and for control. And instead of using that efficient system to then further the efficiency of a bartering system, we went in the opposite direction of completely maximizing this like not invaluable, this something that has no value, and using that as our showcasing our value
Right.
as a human being, you know? And that's completely against everything that we hold dear. You know, it's so interesting because in this modern world, we have so many conflicting ideas with our intrinsic kind of almost like archetypes of behavior that have existed for thousands of years that are deeply embedded within our genetics that are in that are being completely violated by the modern world.
Mm.
You know?
Yeah, and I think that I would to an extent agree with that statement about the bartering system, needing to go in a different direction, probably, if nothing
Hmm.
else, loop
I'm sure the
loop
bartering
loop
system, yeah.
back around, to it.
Hmm.
But I'd say beyond that, the it would be what probably should have happened with by now is we developed from the initial bartering, system to gold and precious things,
Hmm.
system to gold backed money system. And then from there, maybe we have that period of time where we use no gold backed money, but from the gold backed money system, we transfer it to a more relevant currency, which is a computational representation um, of resource, which
Yeah.
is a great example of that is like cryptocurrency and Bitcoin.
Hmm. Yeah.
Like those provide anonymity, and they provide security, and they provide a representation of the current most valuable thing in society, which is computation.
Yeah.
And um, the I'd say that would have been the great next step for us to take there. It would be to transition from a gold backed system to a computing backed system,
Hmm.
and then from there, I don't think it's a necessarily a loop back around that what needs to happen. It is a complete departure from that system in
Hmm.
general. It's because you have such a renewable and computing systems and in technology systems set up, you no longer have to barter for those basic things that
Yeah.
you need to live
Hmm.
from now on. Any bartering that you do could be done directly, but it would be for luxuries, niceties, things that like exist
Yeah.
beyond what your needs are,
Hmm.
and maybe even knowledge and training, and
Hmm.
you could trade those things like I train you, you train me kind of
Yeah.
thing.
Yeah.
Um and
I guess that's really what I mean by the loop around to the bartering system is that,
yeah,
like an exchange that
of
is optimized and
not
altruistic.
required necessary
Mhm.
resources,
Exactly.
but optional and resources that help
Mhm.
improve
Yeah.
lives,
Like if someone's like, "Hey, let's say this one specific community grows these like crops A, B, and C, and then we have crops D, E, and F, and there there wants to be maybe community A kind of wants to trade some of their resources for maybe some more complex foods. Just try something different, and if they say no, that doesn't mean that they go hungry.
Yeah.
You know, and if if one of maybe they want to borrow somebody's um, engineer so that they can help with this project, and they say no, that's not going to collapse their infrastructure.
Yeah. Yeah.
It's very optimized bartering system that is based on if you help me, I'll help you with some stuff, and let's do this. There's no reason
Yeah.
for this to be a
An
problem.
adversarial
Hmm. And you
thing.
can't really dominate someone
And
in
then
that
nobody,
environment.
yeah, exactly. Nobody gets like can require more than is the other person is willing to give. Like it's not like a matter of okay, well, gas is now $4 a
Mhm.
gallon or $5 gallon because I say so, and you have to pay that if you want gas, kind of thing. It is
Yeah.
I'm willing to pay whatever I feel like this is value. Like I want to give back
Yeah.
whatever I think this value is. And if it's not worth that,
Mhm.
I just don't do it. It's
And
not necessary for me to do it. I just don't,
mhm,
you
and
know?
at this and if we're getting to the type of civilization that we're talking about, there might not even be a need for, if somebody says, "Hey, if you wanna have my gas or my energy, it's gonna be this much." Like, well, we've already optimized all of our energy, and we don't even pay for it,
So there's
you know?
there's not a need driving or a like essential nature,
Exactly.
driving pricing and things that allow people to take advantage of people's primal needs or their like vulnerability in
Mhm.
um but instead it is simply what is the current state of society and where it's at, like what
Exactly.
is it valuing, if it's really valuing things like learning programming, for example, then programmers are going to be in high demand, meaning the people to train them are going to be in high demand, meaning
Yeah.
that they're going to get high value for their services.
Mhm.
And so it becomes this adaptive kind of commodity
Mhm.
there.
And I do think that, we're in an age of information, right? And as we continue, the technologies that are going to be made for optimizing, understanding that information and integrating that information into every individual is going to continue and continue to where we get to the point to where we have complete and total control of the manipulation of what we know,
Mm,
to where it's completely optimized in every aspect. Like, I don't even think that's far off. I think that's honestly, if if we get ourselves together, I think that's within our lifetime, you know?
well, it depends on how you define lifetime. For me,
You
I
you know
define lifetime as a pretty long
Yeah,
period of
exactly. We're
time.
planning on living for a pretty long time, so it'll maybe that might be 1,000 years in the future, but
Mm,
if we're getting to
as long as I live that long,
yeah, I mean, if we're getting to technology that helps us live that long, you would think that other technologies would probably develop alongside that rapid development,
yeah.
you know?
I mean, you have a single person with a single train of thought that long of a time, you're bound to come up with something cool.
Yeah, that's for sure,
Mhm.
I've, been trying to that's why I've really done a pretty big deep dive into genetics recently, really making sure that I understand all of the principles of it and how to manipulate it, how to test it, personalized medicine especially,
I'd say if I wasn't
you
going
know?
into like
Like even
neuroscience or machine learning, and I wasn't interested in something like physics, my
Mhm.
next choice would probably be genetic research
Oh, yeah.
because
Oh,
that
100%.
to me is like another untapped area and a very, very like
Mhm.
crucial area.
Mm. So crucial, so crucial, like, understanding our genes, our DNA,
Hmm.
and then being able to fully map out what turning off any specific gene does, how it affects other genes, and the expressions,
The
the changes that
interactions
happen.
between
Yeah.
them, not only first order interactions,
Mhm.
second order.
Exactly. It continues.
Yeah.
Like, understanding that, there's no better way to optimize our health and our
Lifespan.
lifespan. I mean, truly. I'm it's, there's, like telomeres, you know what those are? They're kind of these, um, DNA sequences at the ends of chromosomes that over time that pretty much decide the lifespan of cells,
Okay.
as well as the process of when they die, like when they go really, really
I
short.
could see that being useful for
Mhm.
areas that needed a shorter lifespan.
Yeah, exactly, and using different technologies, we can understand because it's a little more complicated than that. There's, there's ways to optimize which ones actually you want to cut off and which ones you wanna keep extended. And if we were able to fully map out that manipulation process, that would have such incredible effects,
Oh yeah,
for
you
our
could
health.
cause you could cause regeneration in areas that needed regeneration. You could cause
Mhm.
um uh they decrease in cell growth if you needed to for things like cancer and
Mhm.
whatnot.
Yeah. Yeah, and, like the zombie sentient cells that are supposed to die, they don't replicate, but they actually just stay there alive. Even though they don't replicate, they don't do anything, they just go around and inflame everyone else, and kinda just cause a bunch of ruckus and a lot of problems.
Sounds like a
And
bunch of humans
so
I know.
exactly, we're very much like our own internal systems, I will say. We're the expression of all of them.
Quite a few
So we
humans that might as well, not even be alive, but like go around and cause a ruckus amongst other humans.
Mhm. Oh, yeah, for sure, definitely. And these guys
Probably pretty rude. My bad.
but, I mean, is it wrong?
I mean,
They
honestly,
they
if you're
won't know what
causing
you're talking about.
inflammation, you shouldn't be there.
Exactly. You're practically an arsonist at that point,
Yeah.
you know?
You're
Probably
causing problems,
go to
bro.
jail.
Like,
Go to the firing squad.
either get back to where you were supposed to be and don't cause inflammation, or
Yeah.
don't be there at all.
Mhm. So, it's, and I think that it's one of those like, you're right, it's one of those fields that holds so much potential and holds the path forward when it comes to health and longevity.
Keys to unlock this mystery.
And if that it and, I don't know if that mystery's already been unlocked. I mean, there's probably a couple billionaires that wanna live forever too, you know? Who knows how much funding they've done into different projects that are meant to optimize their own specific genetic disposition. If I can do that for myself, might as well. Both of us, you know? We can do it ourselves, that's the great
Imagine
thing.
only having $1 billion.
Oh,
Jesus.
dude, that's nothing. Should see my
I
bank
put
account right now.
$1 billion every day into this stuff.
Exactly, into the setup. That's why it's just so good. The audio is just phenomenal,
Mm-hmm.
you know? We put $1 billion into it.
Why we've got a whole crew.
Yep, three guy crew. They're doing great. So,
Bob, Carl, Jerry.
oh, Jerry, Dave. Yes, you're doing great, guys.
Oh, that's right, Dave. Yeah, I
Mhm.
forgot we got fired Jerry.
Jerry's gone. Bye, Jerry. Yeah, I think quantum biology will be pretty cool too. It's an emerging field. Want to do that?
I would need to know more about it to understand the
Yeah.
relevance or the
Um,
potential relevance.
uh, Understanding how different biological processes utilize different quantum information processes
I say we should probably first figure out genetics
to some
and
degree.
then maybe figure out our connection to the quantum.
Well, I think we can do both side by side. Like there's
Consider how long we've known about genetics, though, and how far we've gotten.
we've gone pretty. I would say we've done fairly decently for ourselves, and this is the most exciting. This is the most exciting time to learn about genetics because there's like the Casper or the CRISPR um, gene testing system that's like their newer models that are really good for like genetic sequencing are really cool. There's just so many cool things that are coming out and it's going to continue to rapidly develop. And so I think alongside that, we can kind of look how, specific enzymes that, utilize quantum tunneling to bypass energy barriers for, their specific processes. Like that's kind of cool,
It is
you know?
it's super cool. But I think as far as like relevance and order of utilization and learning, we should probably first finish figuring out how our brain works.
That's true.
And then we should figure out how our genetics interact and work and how to control them in order to be able to resolve things that we have yet to be able to resolve, such as
Yeah.
cancer,
Hmm.
or some types of cancer. And then we should invest into
I guess so.
detailed quantum biology.
I guess you can put on the
I
back
don't know. In
burner
my
for now.
brain, like I could see value in advancing that earlier and some potential benefits that could come, from that. But to me, it feels like skipping like a step. It's like trying to learn.
Yeah.
It to me, it kind of feels like almost trying to learn um, how to make a custom LSTM cell without first understanding
Oh,
all the components of an LSTM and how they work
yeah.
together. you
Yeah, I
know?
guess that's true. That's true. Uh, I mean, to kind of push back on that, I would say if we have a pretty comprehensive understanding of the simpler components of systems, but there's an aspect to them that's rather complicated. Even if we don't search for all of the quantum components of these biological processes, there are certain ones that complete the picture for simpler systems within ourselves that maybe don't deserve an entire field and billions of dollars that gets funded into them, but still deserve some attention because we know the outlines of the structures that exist completely classically, and then completing that picture quantumly, that's the information's there, like, it's just
Right.
there, and just kinda putting those 2 together.
I can see that, and I would say that, that in general, I'd agree that it's worth those things are worth putting effort towards exploring. However, given our current society and the limitation of resources and what for
Yeah,
this kind of stuff, that's the context in which I'm kind of thinking under, and in that context where you have limited, kind of limited ability to research things. You know, to me, it's like, okay, we could spend a long time, like, researching into this area and maybe eventually get somewhere that has, that has some relevance that we can utilize.
mhm,
Or we could put everybody into this area that really needs fleshing out right now and has immediate relevance, as we figure things out,
mhm.
and finish our understanding of that before trying to move on to this other super complicated area.
No, I agree, and honestly, kind of I like that you mentioned trade-offs because there's a fundamental trade-off problem that we have to deal with in genetics, where we have these, kind of like the core genetic structures that underlie our biology have this trade-off function that trade, uh, immediate goals for long-term longevity. And that is a problem that we really have to overcome if we're going to genuinely move past this kind of 100-year kind of deadline that we have and into the world of 200, 300, where you have unless you get, blown up or hit by a
Or you
plane.
find a way to supplement your immediate needs in order to be able to allow that trade off to focus back on the long term
Exactly.
needs. Yeah.
Mhm. And so it's about that process, and I would agree that that is infinitely more important than understanding how quantum tunneling plays in specific enzymes, you know?
Hmm.
Like, even though it's very interesting, you know?
And could have some potential significant
Yeah,
applications.
totally. I mean, who knows? Maybe eventually in 50 years, there'll be this new quantum medicine
Hmm.
field that pops up because of what we
Yeah, it
can learn
has
from quantum
100%
biology.
bioavailability. Like,
Yeah, exactly,
yeah.
It's, that's actually an interesting topic that once we kinda know a little more about this, I would love to dive into, uh, figuring out ideas on maybe completing the picture from a quantum level that then helps us further manipulate, and refine our manipulation of different medicines. I
Hmm.
think that's something that will definitely play a pretty big role in the later years of our
Oh
lives,
yeah. Um, relatively, or
relatively.
yeah.
Yeah.
Um, there's a lot of lack of a lot of fields that have a lack of kind of full understanding that I feel like would be really beneficial to things like
Yeah.
medicine, and like, um our cells in a lot of ways, are controlled by, your electrical polarities, and um and so if we could figure out, detailed mechanisms of of controlling those even on an engineering mechanical level.
Mhm.
Like,
Yeah.
if we could figure out ways of influencing those in certain, sections of the brain, like in understanding that interaction between electricity or magnetic fields and
Yeah.
the electricity and fields that are in, cells, um, then who knows what applications, that
Yeah.
could have for medical and
Mhm.
health uh,
Yeah. It would
technology.
just help us better predict what is needed for like specific needs,
Mhm.
and we'll have better tools to prepare those needs. Like understanding the problem is half of the solution, you know? And then the other half from that comes very
Resolving the
naturally from that.
problem, yeah.
Mhm. Yeah. So it almost like it'll unfold itself once we get
Oh,
a
yeah.
complete picture, Once we have the formula, we put in the like the inputs, it comes out naturally.
Mhm.
And I think the same will be, I mean, though it'll be fairly difficult to complete that formula, and there's gonna be a lot of them, but
And
I
sometimes
think
you
we'll
don't
be able
even
to
need
do it.
to fully understand the problem as long as you fully
Yeah.
understand the base from which the problem arises. And
Mhm.
so
Yeah.
if you can understand how to control the base, a lot of times you can find ways of controlling the problem, which would then lead you to understanding of the problem.
Oh, yeah, for sure. I mean, I think it's actually very relevant when it comes to genetics because, if you look at, like, let's say, um, a lizard that when you chop off its tail, you can regrow it. How does it know to fully form a tail?
Mm.
That is something that is not understood at all. Why does it stop? Why does it know to
Why
reform
doesn't
that
it keep
specific shape?
why doesn't it reform a foot? Yeah.
Exactly. Like, there's so many unanswered questions there that we don't have to answer in order to know the foundational principles of what is needed. We don't even have to understand its functions, but the actual substance, what is needed in order for it to
The
determine its
action
growth.
reaction
Yeah,
relationship.
exactly. And the same can be true for, let's say, for an amputee. If we don't have to mechanistically, one by one, little by little, re-stitch and grow an arm, what we can do is we can determine what is needed to start the fully forming process of that arm without needing to do it
What prompts
sequentially.
the desired
Mhm.
results and outcomes?
Exactly,
Yeah.
and it's
And then by understanding what prompts it, you can understand the details of that interaction, and through that,
mhm,
further understand the mechanism and problems and whatnot themselves.
yeah,
Yeah,
mhm,
it's really interesting. It's kind of like depends on which facet like you choose to go after first, and
yeah,
also probably which one has the already has the higher level of understanding,
mhm,
towards it slash would be the easier one
yeah,
to try and
mhm,
analyze.
and we're not there yet, obviously. Can't grow any arms,
We've gotten made some good
but
progress on that up front.
we've
Yeah.
made some really good progress, and I think that that's why now is really the time to be excited about this because we're finally making some major breakthroughs in understanding really core principles about how we work, how cells work, how stem cells work, how how we start from a
Imagine if
single cell
someone's
embryo.
heart was failing, and instead of needing a transplant from somebody else, like, or an implant
Mhm.
or a mechanical, addition that is prone to failure, imagine just being able to take some of their cells and then
Yeah,
regrow it and give them a brand new version of their own heart.
exactly. Yeah, to where you don't need to take it out.
You
You
don't
don't
have to worry
transplant, no
about,
nothing.
like, the genetic,
Mhm,
rejection and whatnot.
exactly.
Um,
It's you,
it's you. Yeah.
fundamentally. And if we're able to grow from a single cell embryo into what we are now, if we are able to utilize this process on a more specific scale, like regrowing a heart in that way, we don't need to do it ourselves, we can stimulate the necessary processes for the body to do it on its own. And that right there is the key to success and practically living as long as possible, you know?
Yeah.
Like there's no
Ideally, I mean, like biology would regenerate
Mhm.
itself indefinitely.
Yeah.
Um, I
Higher
think that we'll have a ton of intermediate steps before we get to that point that require, other
Mhm.
methods of extending lifespans.
Yeah.
But ideally, at the end point, I think that would be the case.
Mhm. I mean, it's just, more higher order autopoiesis, you know?
Yeah.
It's not just systems within a system maintaining its own parts that create a coherent whole. It is the coherent whole that is the optimization process itself for the macroscopic organism,
Mm.
you know? And I think that's actually something that the body can utilize
That's one of the
fully.
one of the really one of the coolest things that I think about human evolution and our brains and what makes, kind of gives us that unique quality is even the concept that someday the brain, which is the result of our biology, the brain could figure out and control externally factors within the body that need changing and adapting for
Mhm.
survivability. So essentially, the brain acts as almost like um, this high level view of things that can see things in a way that your body's biology can't.
Yeah.
It's its own mechanisms for regenerating and
Mhm.
protecting things
Yeah.
in a way that it can't, and understands it in a way that it can't, and so can, as a result, take necessary steps with the larger goal in mind, in order to preserve,
Yeah.
and like almost like a parent making decisions that are in the best interest of a child that isn't going to like the decision being made.
Mhm. Yeah.
It's like your body might not choose to make that decision on its own, but
Mhm.
you can see from this high level perspective that is needs to
Yeah.
happen.
And, it's hard to say if that I don't think that brain process could probably be a conscious one, you know?
What do you mean?
Like, that that higher order, like, I think I'm gonna grow a brain. Maybe can have that initial or sorry, grow an arm, but it's an actual, like, uh
That's not what I'm referring to. I'm referring to the ability to take actions that you're to force things to happen consciously, um, within your biology because of your conscious state.
mm,
Like, your conscious mind is aware of what problems and knows enough about those problems to know there are certain actions that need to be taken that your biology isn't gonna take on its own,
yeah.
and so it forces your biology to take
Mhm.
them even though it might not want to otherwise.
Yeah, yeah, I
And
guess
so, like, it's that ability of it's and we already do that to an extent with, like, medical, common, medicine and drugs and whatnot, and that we do. But, like, doing it onto such an intricate scale where we have such an understanding of the body that
Mhm.
we now know enough about the system as a whole that we are able to optimize it and regulate it
Yeah.
from this conscious state.
Mm, I see. I guess in my mind, what I was thinking about was if there is that optimization process that we can enact, then that would have to be almost something kind of like the our kinesthetic awareness of our own body parts, to where it's kind of more
My subconscious.
a little more subconscious, that is a preformed state of affairs that is activated when there is an error in that representation.
Right, but it's the thing that fascinates me there is in the this is what I'm kind of referring to, is that the ability of the conscious to understand the body enough and its mechanisms enough to be able to see where that missing link is in that connection, the inability of the body communicating with the subconscious or the subconscious communicating with the conscious, that
Mhm.
missing portion that's not allowing that process to happen, and go in there and prompt it and resolve it,
Yeah.
you know?
Mhm. Yeah.
Like, that to me is the
Mhm.
fascinating kind of
Yeah.
component that just, like, blows my mind that, like, that no pun intended, but, like, is the like, it's wild to me that we could potentially get to a point where we could have that loop and that meta understanding of the process that we could interactively make choices for our own
Mhm.
knowledge.
That w that is such a interesting concept, and I don't know if it's exactly far off from what we can achieve, because at first glance, it might seem fairly complicated. What if instead of complicated, it was taking something that was intrinsic and maximizing its performance
Yeah.
to where the 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 data is already there. Even if that arm is cut off, you have a phantom limb that's still
You
exactly
remember how that
represented. Yeah.
feels, yeah.
Mhm. And the genetic factors that played into, making that arm
Also, you initially
still
developed the
there.
arm.
Exactly. If you can initially do it, you can definitely
That's coded
recreate that
somewhere in there.
process.
We just
Yes.
have to access it, right? Because 'Cause we're
Mhm.
not designed to do that naturally, like, as adults, we're not designed to be spontaneously like, generating new
Yeah.
fingers or whatever.
Very few animals can do that.
So we have that conscious understanding enough to know where that information is stored,
Mm.
take it, utilize it temporarily in a process that it wouldn't normally be able to prompt, stimulate it for the sake um, of immediate
Mm.
survival or
Yeah.
needs, and like, that just like kind of really comprehensive understanding and influence of such an intricate
Mhm.
system just to me is
Mm.
beautiful.
And
Like,
yeah.
it's the ability of an overarching area to cover the weak areas of a
Mhm.
system.
Yeah.
It take care of those things they can't
Mhm.
do for itself, you know?
Exactly, it's interesting because we're made up of a bunch of tiny microsystems, right? We like to think of ourselves as a unified whole, but really that unified whole is really just our thalamocortical system just integrating with information with the cortex and other, you know,
Right.
brain systems.
Well, we are the sum of our parts.
Exactly. We're the sum of our parts. We're the integrated information of all of its, dynamic interplay, And if there was a way to establish a higher order communication network between the needed systems that act independently because they have their own environment and don't need to change its functions because it already did. But once we have a higher order understanding of how to activate those functions again, that were the precursor to how do we developed, then there's no need to, um, uh, or I guess there's no reason why it wouldn't be able to recreate that process
Mhm.
if it was able to establish the correct communication network. It's about communication because that's fundamentally what we're missing, is we have these cells that have their own have their own environments, own conditions that they know they need to work in, and those are intrinsic, but they're not aware of the whole system. Like, they're not aware of what the in a clump of 10 cells, that those cell systems are not exactly aware of what the other cell systems are doing, you know?
Mhm.
And those individual components
They
aren't
don't have that
aware.
high level view.
Exactly, they don't have that high level view. It's those interplay responses that then change those microscopic environments that then lead to that developmental process, right? It's a beautiful, incredible process that happens. Even more beautiful if we're able to continue the stimulation of that process when needed, you
Mhm.
know? And that's I don't I wish I could go into the mind of a lizard and how he feels when his tail is getting regenerated.
I think it'd feel pretty weird
A little weird.
to know how it felt to have a tail and then also have a tail that was missing
Sure.
and a tail that was growing back. I think that would be wild, wacky. That would put an imprint on my mind of a phantom tail where I would now feel a tail just everywhere where there was none, and that would be too weird.
I'm developing a phantom tail right now, just thinking about it.
The phantom of the tail is here.
It regrows. Yes.
Alrighty. Well, that was quite a long podcast.
That's for sure.
And
we're able to get
as much as we could keep on going, it is now 2:28 in the morning.
God.
So we probably better call it here. I don't think anybody's still up and watching this, even if there was some people watching it earlier. But yeah, it's a nice and long podcast. A lot of interesting stuff. I didn't even notice time go by. So
me neither.
Good sign.
Very good sign.
Thank you guys for watching. If there is anybody still watching, appreciate you guys.
Yes.
Sticking around and listening. And
if you're in the edited video watching this, thank you guys for watching.
Yes.
Wonderful.
Indeed. And let us know if there's anything specific that you would like us to cover in future podcasts. And we will try and make sure that that happens.
Oh, yeah.
And yeah, make sure to join us next week for another deep dive beneath the ThetaWave.
Yes.
Have a good one.